This conference will now be recorded.
Yes, hello everyone. I hope my screen is also visible online.
Yes, sir, your screen is visible now.
Yeah, okay. So today we will be starting with front end demo session. Okay. Uh, First of all, sorry for the delay. Okay, in starting the session. I know that session needed to be started at 9:30, but due to some things, right? I reached institute late. Okay. So before starting with the demo session, right? Just wanted to know, like, you guys are all completed your engineering, or you're pursuing your third year or second year? Pursuing engineering. Okay. So, what about online guys? Okay. So, few have
Completed, sir.
passed out, few have completed recently, few have pursuing fourth year, right? So, okay. So, what I would say is, if you're pursuing third year or fourth year, right, it's actually a good time to start with your VLSI career learning, actually, right? So that by the time you complete your fourth year of engineering, you'll be good thorough in the knowledge of what VLSI had to provide, right? And you can also crack the jobs as well easily, right? Okay. So same thing goes to even people who have completed also. So it's a good thing that you have joined VLSI to learn VLSI. Okay. So before that, right, before starting into the demo sessions, what was your interest to come into VLSI domain actually? Why not go to some other domain? Why did you choose VLSI? I just want to interact before starting, right? I just want to interact. So I wanted to know why you guys have opted for VLSI. Why not any other field, like computer science is there, right, which is software, which is also going on. Even online and offline, you can unmute and you can answer. I'm not pointing out anyone. Whoever wants to speak, you can share your opinions. Okay. Real time, there is no scope for IT related, so you're opting for okay. EC background. So your EC background, you shifted to IT. So now you're coming back to VLSI. Yeah. That's a good thing. What about others? Anyone? People who are pursuing
Sir, I recently
electrical.
graduated. My background is electronics and instrumentation.
Okay.
In that case, I choose VLSI because it is a chip designing evergreen subject now.
Okay. Can you please repeat your answer? I was not able to hear you at the end. Lokesh, I was not able to hear you. Can you please repeat again?
సార్ ఇప్పుడు విఎల్ఎస్ అంటే చిప్ డిజైనింగ్, దానికి ఎండింగ్ అంటూ ఏమీ ఉండదు కదా. మనం ఏ ఫోన్ వాడినా ఏది వాడినా దానికి డిజైన్ అనేది కావాల్సింది కంపౌండ్, కాబట్టి విఎల్ఎస్ఐ చూస్ చేసుకున్నాం.
I'm sorry to say this, but I don't know Telugu. Okay, can you please say in English? I don't know Telugu actually.
ఓకే సార్. సార్ we daily use mobile phones.
Yeah,
It is made up of some designs and chip loggings,
correct.
motherboards, all any hardware component is majorly development in VLSI only. In that case, I choose this background.
Okay, so you are like, is it like you're saying that you want to know how the things work in your mobile phone and your laptop, so you chose VLSI?
Yes, sir.
Okay, that's a good thing actually, right? So you're using something in a daily basis, right? That is your mobile phone, laptop, right?
Yes.
Whatever you mention electronic product, you're using every day. Washing machine as well, right? So these are basic
Yes,
needs
sir.
actually, right? So if you're
Uh,
if you're having an interest to know how the things work, yes, obviously first thing starts with VLSI itself, the hardware designing part, right? Chip designing part,
yes,
correct.
sir.
Yeah, that's a good intention to opt for VLSI. Okay. See, high paying. Someone is saying high paying salary. Okay. You go for IT also, you'll get high paid salary. Only thing is what, even in VLSA also, it's not like you don't know anything and you'll get high paid salary. It's not like that. Go choose anywhere. If you're having interest and if you're having passion, you can learn things more thoroughly, and at the end of the time, you will get a high paid salary. Right? It's not only for VLSI; it holds true for others also. Okay. Okay, fine. So let's start with the demo session. Okay. So, uh,
Oh, hi, sir. I just have
yeah,
a small question. Sorry to
yeah.
interrupt you. Yeah. So actually, right now I'm working as a software developer. But my bachelor's was from electronics and communication. So it's been 4 years. But now I'm thinking to switch my career to electronics, like core side.
Okay.
So what I'm thinking is like I want to be a design verification engineer. So like does it is it good option to switch my career like what are the things like that I need to be careful like if I want to be a design verification engineer?
Yeah.
Can
Okay.
you
Let me tell you that. Okay. Before going discussing this question, right? One thing I would like to say, these type of questions I will address at the end. Actually, we'll keep it at the end because first let us understand what is VLSI. Since you have asked the question, I'll just respond to this. Okay. First thing is, your background is a VLSI, you told, right? And second, you told that you're working in a software domain, nothing but a coding aspect of your job, right? Coding
yes,
aspect means what you might be familiar with. You are already familiar with C, C++, basically OOPS oriented programming language. You are familiar with it, yes,
it's correct.
right? So it will be a very good choice for you to join design verification. That is front end design verification. There is one training present. I mean, we are doing the same thing, training itself, demo itself as of now. Okay, that's a very good choice. Why? Because in front end design verification, right, what we have is we have coding only. 90% it is coding oriented. It's actually okay. The 10% what is there, you use tools. Why you use tools? To check whatever you wrote the logic, it's correct or not. You use tools actually through waveform and through some kind of checks what tools provide. Okay, so uh, design verification is a good choice for you. Okay, coming to switching from software to design verification, right? There is no harm in doing that. Since your background is already a EC and you're already having an coding background, you can also switch from IT to VLSI domain. You can still do that. Okay. The last aspect what comes here is basically how do you want to join in VLSI? Like you want to show your previous software experience uh, as a VLSI engineer, or you want to show your software experience as it is and you want to join VLSI as a fresher. These two things, it's all based upon you actually. How do you want to join? Okay. Did you understand what I'm saying? I didn't
Yes,
get
yes.
your name.
Yeah, it's a Krishna here. Yeah, I got
Yeah.
like what you're saying. Like, yeah. So, yeah, one more question. To add up to this, yeah, if I choose like whatever the experience I have, if I keep this present experience in the VLSS side, so it might be like 3 to 4 years of experience, right? Like, is it like if we can focus, like still we can manage the practical experience like that we got, or like, or will there be any struggle in it? Generally, like I
Can you
just
please
want to
repeat?
know.
I didn't get your question. Can you please repeat?
Yeah. So if I go as a fresher, like that will be fine. But like if I keep my current software experience, like as a VLSI experience, so it will be like 3 to 4 years of experience, right? I have. So can this be okay? Like, can I be able to make progress in the job, or else it will be difficult for me to with that
Okay.
experience?
Okay, got it. See, coming to job experience, if you can manage or not after keeping experience as a VLSI in the previous company and joining as a experience in VLSI. That was what your question, right?
Yes, correct.
Okay. See, coming to job managing part, right? You're already industry how it works. You already know, right? From 3 years,
Hmm.
it might be software, it might be VLSI industry, doesn't matter, but you know how a industry works, how a project is managed, how the workflow will be there. You might be already aware of it. Okay.
Yes.
So what I'm saying is now all comes to knowledge actually. Okay.
Hmm.
So now all it comes into the knowledge point of view. So the 3 years of experience, whatever you do as a VLSI 3 years experience, whatever you do, after 3 years, the expectation is what you should be familiar with basics of the design verification.
Hmm.
Okay, basics of design verification. What is there are a lot of things present. Like let me list down it. Basics means what? It starts from digital actually,
Yes.
right? Basics starts from digital. So then it comes with Verilog. See, as a design verification, you might not write a Verilog code, but you when there is some bug present in your verification, right? You need to check where the bug is coming from. In that aspect of the time, you need to open the design files. You need to read this. Like you should be capable of reading it and
Yes, it
understanding
is.
the logic, right?
Okay. Okay.
That is the second aspect where Verilog comes. You need to be knowing Verilog. Third
Hmm.
thing comes to the verification language, that is system verilog and UVM. UVM is a methodology. System verilog is a language what we are currently learning. Okay, and UVM is a methodology is built using system verilog itself. UVM
Okay.
is a currently being used verification methodology in design verification for ASIC chips. Okay, so if you want to uh, means as a experience, if you want to know, right, you should be knowing UVM, you should be knowing system verilog verification methodologies and languages in order to write any particular design verification from scratch actually. What do I
Okay.
mean by that? What do I mean by that? So after 6 to 8 months of your training, if I give you a simple multiplexer
Hmm.
mux, right? Mux,
Hmm.
simple mux. If I give you a design, if I ask you to write me a UVM test bench for it, you should be able to do it. And
Okay.
frankly saying, people are not, means after 6 to 8 months of training, people will not be knowing how to do it. If you are able to do this, you can get a job.
Okay. Okay.
I'm saying this with respect to freshers also. I'm saying this with respect to people who are planning to go as a experienced as well.
Okay.
Okay,
Okay.
why am
Got
I
it.
saying this? Because what happens here is, I'll tell you what happens in student and teacher in 8 months. What happens is, whatever we teach, you will be knowing only that much.
Okay.
Okay,
Okay.
if I teach
Yeah.
you a half header verification, you know to do only half header verification only. You don't know to do. If I give some other design, you cannot do that. You're not able to do that. Now that kind of a skill you should not develop.
Got it. Got
See,
it. Yeah.
you got
Generally,
it
like
right?
one. Yes.
Yeah,
Yes. Yes. Generally, whatever. It's not only the class work. Like we have to be
yeah.
do our
But
homework as well, like to
yeah,
explore more
so
on that.
what I'm saying is, see, we will be teaching you the basics actually. Basics means what? Like how to write a test bench for any design. We'll teach you by taking one design as an example. Now, if there are 100 designs present, we can't do all the 100 verification, right?
Yes.
Do you agree? It's not practical, right?
Yes.
So what we do, we teach. We have a lot of projects. Okay, 4 to 5 projects are there. We teach just 4 to 5 projects how to write a UVM test bench verification. We teach you. Okay, and Verilog test bench, system Verilog test bench, UVM test bench. We teach you that. You should be now. You can't expect I'll get only these 4 projects in the interview. You can't expect that,
Yes. Yes. Yes.
right?
I get it. Yeah.
Suppose if the interviewer asks you some other design, means his means interviewer company specific some, let's say, Wi-Fi router verification, he might ask you to write the test bench. I'll tell you, for some of the freshers, right? What they are told is, means they'll at the final round they'll ask for the candidates to come to the office. They'll make them to sit for 4 hours. They'll give on design to write it, and they're not bothered regarding complete code you have to write, and you have to simulate, you have to get the waveform. They're not worried about that. They are worried about how do you approach that particular design, what all things you are capable of writing it. That's what they do actually.
Okay. Okay.
Okay,
Got it.
now
Yeah.
to learn that, you should be to do that, you should be knowing the basics, so which VLSI institute is providing you that.
Okay.
And
Okay.
how to
Got it.
test bench for you using UVM or using Verilog or using system Verilog. We will teach you by taking design as an example. Like multiple
Mhm.
designs are there. We'll take that as
Yeah.
an example. We'll teach you that.
Okay.
What you should develop, you should develop the knowledge of implementing a verification code for any such designs. That
Yes.
is
Yes.
what is
Got.
expected.
Got it. Got it. Yeah.
Remember.
And yeah, sorry. One more quick question. Sorry for taking your time. So yeah. So what is the ideal time frame to complete this course? Like generally, like I don't get enough time to attend like at the given schedule. So is it a self-paced learning or like only daily based like that we need to spend a particular time for the class?
Okay. Let me clear that also. VLSI Guru Institute is providing two modes of training. Okay.
Yeah.
One is a self-based learning. Self-based learning. What do you mean by
Okay.
self-based learning? Pre-recorded videos are there.
Okay.
Already, uh, already pre-recorded videos are there. We'll be giving you the access for that. Okay, means
Okay.
this is more suitable for people who are currently working and they want to learn the design verification course. For
Hmm.
them, they're not able to spend Monday to Friday time in the institute, right? Because
Yes.
our sessions will start from morning 9 o'clock, and it will be 3 hours morning theory will be there, and evening 1 or 2 hours lab will be there, right? So
Okay.
working professionals, it's very difficult for them to attend. So for them, we are having an option called as self-based learning, where we will provide you recorded videos.
Hmm.
Okay, so you have to go through those recording videos in your own time, in your own pace.
Okay. Okay.
Okay, like, but there is some deadline for the recorded videos as well. It's not like you can take 2 years to complete it. There is some deadline. I will ask my manager to get in touch with you and discuss regarding the deadline. Actually, I think
Okay.
it should be also 6 to 8 months itself. But the only advantage what you are having here is you can see that videos in your own time. Actually,
Okay. Okay.
yeah.
So generally it will be 10 hours of course like per week or like it's more than that or less than that, the
No,
class.
it's not like that actually. It's like suppose digital, right? They'll give you like 2 months of time. Within 2 months, you have to complete the digital. It's like that.
Okay. Okay. Got it.
You can take and you can complete however you want. Like Monday to Friday, if you don't have time, it's okay. Don't watch the videos. Watch the videos on Saturday, Sunday. Like 6 hours, 6 hours, you watch the videos and you complete it. It's up to you how you do it.
Okay. Okay. Got it. Thank you. Thank
Okay.
you.
And coming to the support, actually, now people who do self-based learning, right? It's not like just by watching videos you can understand everything in one go, right? And
Yes.
assignments also are provided. You can. It's not like you can understand the questions in the assignment. You can complete it on one go. Actually, it's not like
Yeah.
that, right? Practical, right? So what happens here is there is dedicated groups present with you. Means you will be added. Management will be added. Technical team will be added. Okay, and finance team also will be there. I mean, basically, VLSI management also will be present. You also will be present. Trainer also will be present. You have to post your doubts in that group. trainer will get back to you within 24 hours. One day, if you give time, they'll get back to you.
Okay, okay, got it, got it.
Okay. Suppose you still have a lot of questions, lot of doubts, then you can request for a one-to-one session in that group. You can request for a one-to-one session. So trainer will arrange that one-to-one session in Saturday or Sunday time, and they can clarify your doubts.
Yeah,
This happens not only for digital, Verilog, System Verilog, UVM, and the projects as well.
got it, yeah.
Okay. This is what the first mode, that is self-based learning, which is
Hmm.
mainly suitable for working professions.
Okay,
Second thing
got
is coming to regular classes. I'll say regular classes. Regular classes, there are two modes of regular class training. One is online, other is offline. Both the cases, sessions will be conducted every day, Monday to Saturday. Now, morning theory, evening lab, it will be conducted. Okay. Now, in
it.
this case, what happens is, uh, means like how we are having demo session now, right? How are we having demo session now? Like you're joining, online guys are joining through the link, offline are coming to the class and attending,
Hmm.
right? So like this, the same regular classes will be conducted. In this case also, you will be having a dedicated WhatsApp groups. Each individual people of you, once you enroll, a dedicated group will be created for each one of you, right? In that
Oh,
dedicated group, what will happen is, in the dedicated group, what will happen is same thing. Management, technical team, and you will be present. If you have any doubts, technical doubts, post it there. Any assignment, see, every day also you will be having regular classes. You can ask your questions there also. Still, you have doubt, you can ask your questions in the WhatsApp group as well. Getting my
okay.
point?
Yes, yes,
Okay.
got it.
So, and your in WhatsApp group, whatever the questions you post, it will be addressed in the one day minimum, 24 hours. It will be addressed. And regular sessions, right? If you ask a question, directly the trainer will solve your doubts. Actually,
Yeah,
it's like that.
got it.
Okay. For both, that is online. I mean, self-based learning plus the regular classes. For both, contents are same. PPT means whatever the institute is going to provide you the access to the materials is the same. No change is there actually. Everything is the same. Okay.
Okay,
Assignments are the same. Procedure in how you can progress to the next module of your learning. That is first digital. Once digital completes, what is the procedure for you to go to Verla? Means what do you mean by that? Some test will be there actually. Like evaluation test will be there. You have to score above some 75 to 80 percentage of that you have to score. Then you will be allowed to go to the next stage of your learning. That is Verla.
okay,
Getting my point?
got
Why
it.
we do this? See, why we do this after each subject? Because to self evaluate, you have to self evaluate yourself actually. At the end, you can't come and say that I know I have done training, give me job. That doesn't happen, right? You have to be knowing the knowledge also, right?
Yes, yes,
See,
yes. Right.
you're getting my point, right? It's fair actually. It's not like you just come attend 8 months, you don't learn anything, you can't expect a job. Even if you get a job, you will be struggling later actually. I'll tell you,
Yes.
you'll struggle a lot.
Hmm.
So the thing is, so we are having self evaluation, means you have to write a test. We'll evaluate on that. If you're scoring more than cutoff criteria, you go to next stage.
Okay, okay.
Got it?
Excuse me, sir.
Okay.
Excuse me, sir. I have a question over here for the online sessions.
Yeah.
When I spoke to the counselor, what she said is you're not supposed to come to the center for labs. Everything is online, only online. So
See,
it
that's what
was
I
a
told, right?
concern to me also at that time because
Uh,
at a times we may be struggling at work alone at home. So maybe we may need some help or something if we or VPN access could be slow, etc. So in that case, we might need online sessions. I mean offline, where we can come and work in the lab, right? Is that allowed? For sure.
okay. So your question was, uh, so you are opting for a regular batch, but through
No,
online
not.
actually, right?
I mean online. Yeah, yeah. Self-paced.
Self-based learning. So self-based learning means you are currently working working professional
Yeah,
and you're opting for self-based learning, right?
yeah, yeah.
Yeah. So as I told you, when it comes to the tools, and see, still you are having an option to come Saturday, Sunday. See, my thing is, suppose for a self-based learning candidates, right? If you are in Bangalore, you can come. You know where, I think you know where the institute is there, right? You can still come to the institute. You can clarify your doubts. That is still an option for you. It's up to you actually. Else you can opt for complete online and avoid coming to institute also. That's also up to you. Now coming to the as you told, right, some doubts are there, or some VPN access issues are there, like for the tools, right, network is slow. That kind of situations are as of now not there. Okay, but it's true that in a month, right, maybe 1 week we might be having some network issue. That is because of there might be some regular software patch updates will keep on happening in server. Because of that, there might be 1 week, there might be you might face the issue actually, but you will not face that issue regularly. Very frequently you won't get it, and unless from your side the network is strong, you will not face any VPN kind of issues.
Oh, okay.
Okay, and second thing is, see, as I told you, right, that self-based learning pre-recorded videos are given. I told you, right, for pre-recorded videos, you don't need any VPN and all. Such kind of VPN and you don't need. Basically, they'll provide you one portal. InSkill website is there, right, for VLSI Guru. In the InSkill website, they'll load your profile and they will provide you the access for the modules. You can go through that in your respective time. Okay. And if at all something issues come up, right, so management will priorly inform you. Suppose tomorrow some you suppose today you are facing some VPN issues, right? So or tomorrow you might face some VPN issues. Management will provide you a message in WhatsApp saying that currently some network issue is going on in institute, so we will resolve it within 3 to 4 hours, like that. And prior information will be given also to you guys.
Okay. Ishwar here. I have one doubt, sir. Like in pre-recorded or in online, offline, what are the tools that are covered in this course?
Okay, tools, right?
Correct.
Hello. Something happened with the meeting?
I think we disconnected. The organizer has been disconnected. We joined.
So no other organizer is in the session, it seems.
Yes. We can wait for some time and.
Does anyone have any idea? Like, does the pre-recorded courses are only for like every week, or like it's a complete course content?
It's not completely recorded, I guess. Like it's just subject wise. For any course, like we
Subject
have a
wise.
subjects, right? Yeah.
No, because we are working professionals, right? So it will be better like the complete topic will be there, right? In one go.
As for the subject, like for suppose, like as I discussed, right? Like it is a design verification unit. We need to
Mm-hmm.
we have a couple of prerequisites like basics of electronics and UV, VLSI and Verilog and UVM. So these things like we need to do. So maybe like they'll go each subject wise. It's not the complete course they will leave at a time.
Mm-hmm. Because
No
when
complete course is provided in which subjects like digital electronics, Verilog, system Verilog, UVM, Ethernet MAC verification, AXI protocol, Python, and Linux. All these modules are provided beforehand, and you can, by your pace, uh, means have to complete that courses and submit the assignment. And there will be a Q&A session. Means you have to score in that Q&A session to get into that job placement group. So before only all that modules will be provided.
okay,
Oh, okay.
okay, okay,
Thank
great.
you. So did you join already, like or
Yeah, means before this I was into that self-paced, but there I was not getting that motivation to go through that videos regularly. So I then switched to this regular one.
oh, okay, okay, got it. How much they will charge generally for this? Ramesh?
Means uh, that one is somewhat less, means 5 to 6,000 less. Let's say this is might be 59, I think, and that self-based is 52 600 something,
Okay, 52K.
6,000 less.
Oh, 5,200 you are saying, or 52,000?
And also in that the we have to ask the trainer to means come and resolve our doubt. But here daily means the daily lab sessions will be there. You have to go. The trainer will the in lab session they will help you to resolve your doubt related to that assignments. But there only when you ask, then the support sessions will be organized for you. So that's
Okay,
also a thing.
But
okay.
in that pre-recorded sessions also they are mentioning that, right? They have a WhatsApp support group where they can.
Mm-hmm. Mm-hmm. Mm-hmm.
So those groups are active or like those are not. Those are like passive groups only.
No, no, active means you get your query resolved within a 2 hours. If not,
Okay.
they will call you. So groups related to groups means all your queries will be resolved within a means as quickly as possible. But
Mm-hmm.
let's say if you have a doubt related to a question in assignment, then they will organize a support session, might be tomorrow or within a week, and there you have to ask your doubt. But here in regular now, what it is, you will be means you will be meeting your mentor regularly basis on the regular basis. So you get
Mm-hmm.
your queries resolved every day. That's the
Mm-hmm.
thing.
Okay. Mm.
Hello.
Yeah, you're audible.
Yeah, I'm
So we
audible,
got
right? Yeah,
yeah.
I'm sorry for this. Basically, there was some network fluctuation, so I was logged off of the meeting. I think now I'm audible, right?
Yes.
Yeah.
Sure.
So what I was discussing was I was discussing regarding the tools, right?
Correct.
I'm not sure where I was cut off in the discussion, but I'll just explain you what I just told. Okay. So is my screen visible?
No.
Now,
Yes,
Yes.
sir.
yeah.
Yeah.
So what I was telling was, I was telling regarding in industry, right? These are the tools which they are using currently, and in the institute we are having this set of tools which will be used by you guys also. Okay.
So here, like synopsis, VCS, Verdi, both will be taught, or any one of them will be taught, like sir.
No, no, both. Basically, Verdi you use for waveform debug and RTL debug and all. Okay, VCS is just a waveform viewer. That's it. Okay,
Hmm.
both will be taught. Both will be taught.
Okay.
Okay. Okay. Even Questa Sim, Model Sim as well, and also the EDA playground as well. Actually. Okay. Uh,
So is it? Mhm. Okay.
yeah. Please tell me.
No, EDA playground is same as Cadence, or it's something different?
See, actually, EDA Playground, it's an online platform. Okay. It's a collection of Synapses, Cadence, Mental Graphics. Means Costa, what I'm saying. It's a collection of all the tools. But no, the thing is, not full license is given. Since being an open source, right? Full license is not there. Something little bit you can do in EDA Playgrounds. Okay, like major things such as coverage report and all, which comes for a design verification, so that you cannot do in EDA playground, but whereas in synopsis, VCS, Verdi, Costa Sim and all, you can do it easily.
Mhm. Okay.
Okay, that's the only thing. Apart from that, nothing is changed. Okay.
Mhm.
Okay, so let's pause the questions.
Another question, sir. Hello.
uh, 1 minute. See, what
Sir,
I'm telling is, let me pause the questions for now. Let me tell you the demo. Let me give some demo on our front end design verification. I'll come back to your questions after later on. Okay. Okay. Uh, so let us
hello, sir.
start with the. Yeah. Please tell me.
Sir, another last question, sir. Sir, whatever the question asked by Krishna, is it applicable for physical design as well?
No, no, no. It is only for front end aspect. I already today is a front end demo session. Okay.
If
For
someone is
physical.
doing for a software job, so he want to switch to PD side, then it is applicable or shall not?
Okay. See here, when it comes to the training aspect, what I told you, the regular batch, self learning, all those things remain the same, but the tools will change actually. Tools will change. Okay. I'm not the
No,
one
no, sir.
to
I'm
explain regarding
sir.
the PD aspect.
Yeah, I'm not
Okay.
asking that, sir. Actually, I
Uh,
want to know that whatever the question asked by Krishna recently initially. Let's say
hmm.
he wants to transit his career from software side to VLSI industry as a front-end developer, front-end side.
Yeah.
Can a person who is doing software job as a developer or whatever the testing, whatever the role, if want to transit his career to PD side, it is DB, he want to switch to PD side. Is it applicable, sir?
Okay. Let me tell you one thing. What is physical design is, you need to be knowing lot of theoretical aspects. Okay, like CMOS working, transition, how it work, all those things you need to know. Op amps, amplifiers, right? You need to know all of those things, how it works actually. First thing, theory is too much is there. Theory learning is too
Sir,
much.
voice is little breaking, sir. It's I think some drop is creating between your voice. A little
Okay.
bit creating.
Others, am I audible? Or for you guys also, my voice is breaking.
Yeah, yeah, it's little bit clear, sir. Okay, it's okay now.
Okay. Let me just give me 1 minute. Yeah. Now, can you please
Yeah,
check
it's
now?
okay. It's okay. Yeah,
Yeah. Okay, so what I was saying was, see, physical design, that is back end is there, right? It's lot of
yeah, yeah.
see, front end is 90% of coding, 10% is the tools. Theory is, let's say, in 90% of coding, right? Let's say theory is 30%, and remaining percentage is remaining 60 percentage is coding. Okay, and the coding is all about theory itself. Whatever you learn in theory, the same thing you learn in the coding. It's like that actually. Okay, but in terms of backend, right, there are other things coming. Like you need to know in-depth knowledge of how a transistor work actually. Okay, so how using the transistors, how do you implement gates? In-depth knowledge you need to be knowing on that. That is where
Yes,
backend
sir.
comes. Okay,
You know.
so backend is all about 80% of the time you'll be learning about theoretical aspects. Theory knowledge is more needed there, and only 20% is the thing where we need coding. And coding is all about script actually. You will be using TCL script, mainly TCL you will be using. Okay,
Yeah.
now what my personal opinion is, suppose if you're doing a software job, you're already doing a software job, you will be already
Mm.
aware of some languages, right? Programming language, you're already
Yeah.
aware of it, right?
Mm.
Majorly is object oriented programming language.
Yes.
Better go with front end design verification role, because it will be very easy for you to learn. Okay, that's the main thing. Learning
Okay.
will be very
Yeah.
smooth for you. Okay.
Okay, sir. Okay. Thank you, sir. Thank you.
Okay.
So one quick
But
question.
it's all up to you. If you are having interest in learning about CMOS, all those things, too much interest if you are having, then you can go with backend as well. It's all up to you.
Actually, sir, I'm basically from electrical background. Uh, okay, it's okay, sir. I'll do it.
Yeah, sure.
Thank you.
So the design verification in the sense like we have a both for front end and back end separately. I thought like
Design, I'll tell you all those things. I'll tell you what is design verification, where it comes, all those things I'll explain.
oh,
Allow me to start with the demo session. Okay.
okay.
Please, at this point, I have to say, please. I'll address your questions. Okay. Because it's not that I won't address your questions. I will address your questions. Okay. I'll explain you. See what VLSI, right? What are the domains it has? Okay, where backend? What is backend? Where backend flow is there? What all things are given by backend flow? What is front end? What are the engineers which are coming from front end? All those things I will tell you. Okay. Okay. So course agenda here is basically today we are starting with our course. So today we'll be doing with our demo session. Where in the demo session, what I'll be telling you is I'll be taking a simple electronic system as an example. I'll explain you how using the electronic system, right? I'll explain you how it works. Okay, where VLSI comes into picture, where what is the difference between backend and means in the VLSI design flow, right? For electronic system, how the front end design flow is there, how the back end design flow is there. I will explain you. Okay, I'll also explain you regarding ASIC and FPGA based hardwares, right? I'll also explain you what is embedded systems, what is VLSI systems. I'll also explain you what are the job roles provided by VLSI. It might be in the front end or it might be in the back end. Skills required for you to the join the course. Okay, so also the institute will also help you in choosing a right domain for you also. Okay, how are the institute facilities are provided? I'll explain you that as well. And we'll also give institute, right? As an institute, will also help you in preparing for the jobs as well. So preparing for the job which you should be doing from the day one of the training, but dedicated job support preparations also will be provided once you complete your basic subjects actually. Okay, basic subject once you complete, so we'll provide you some additional training for you to prepare for the jobs as well. Okay. Why do you choose a career in VLSI, and some placements will be discussed by our manager. Okay, I'm not the right person to speak regarding placements. And at last, whatever you have questions, I'll address your questions. Okay, and we'll wind up with the demo session. Okay, so yeah, so course is starting today, right? Okay. Today, right? What we are starting. is with, we are starting with front end design verification training. Okay, so so that's the reason we are doing today design front end demo. Okay, similarly there will be demo for back end as well. Okay, and they'll tell you when the course will start for the back end. But as of today, we are starting with what, front end demo session, and the trainings which are going to start from today onwards is, first is design verification training. Okay, so uh, before saying this, right, I would like to ask one more thing. Is there any candidate in this meeting who are already experienced in front end design, who are already working as a front end design engineer, and they want to upskill their knowledge? Anyone as such joining today's demo session? Okay, I guess it's not there. Okay. Why am I asking this question? Because there is one course which is for experienced also. Means experience means one, already you are having 5 years of experience in your in VLSI, and you want to upskill yourself. Okay, so such kind of training also is present, but I think no one is joined in today's demo session. Okay. So if you need to upscale, right, if you need to upscale, there are variety of projects present in our institute. Okay, starting from USB controller projects, memory controller projects, some protocols are also present, assertion trainings also are there. You can reach out to the respective management to understand if you want to learn anything else actually. Okay. I'll address your questions later on. Okay, please hold on to your questions. Okay. So let us understand electronic systems actually. Okay. So you take a mobile phone. Okay. What are you able to see in this mobile phone? This is the phone what you are using. Inside that phone, it looks something similar to this, whatever you're seeing here. Right. Now, what all things are present? There is camera module present. Speaker also is there, right? Microphone also is there. Speaker also is there. And you're having the main motherboard, right? And you're having some video processing chips are present, right? And you're having some battery power units are present, memories are present. Such way, if you take a mobile phone, it's not only what you use actually, whatever you see and whatever you're using, right, it's all software actually, right? Do you agree? Whatever you interact with your phone to do call, or to watch movie, or to do chat, whatever you do, that's all software aspects. So mobile phone is not only software, it is software plus hardware you can't see. If you want to see, you have to break the phone, and I'm not sure after you break the phone whether you can use this phone again or not, right? So mobile phone, right, what you have, software plus a hardware. So what are hardwares you cannot see because you have to break open the phone to see it. Okay, so before mobile phone comes into your hand, right, first what happens, first hardware development should happen, right? Do you agree? Suppose let's say the Apple phone, whatever they're showing here, right, it uses what, bionic processors, right? A bionic processors it uses. So it's a SoC, system on chip. We call them as a system on chip. It is example of such is what, Snapdragon also is there, right? Now Google also have their own processor, Tensor processor they are having, right? Snapdragon also is there. Like Oppo, I think OnePlus phones and all, they're coming with Snapdragon phones, right? Even your laptop also, the main component of a laptop is what, the motherboard, which has a what, the processor, system on chip. It has Intel or Snapdragon also. Now they have left some processor, Elite something is there, which is used for laptop as well, right? And also you're having other AMD processors also are there. Now without this processor, do you think your mobile phone will work? It won't work actually, right? Because your processor is the one which manages the other components of your mobile phone or a laptop, right? So that is your speaker or your memory in your mobile phone and laptops, right? It's all managed by your processor itself, right? So all these hardware components starts with what means manufacturing starts with VLSI front end actually. Okay, where first the architects come, means architects they take inputs from the customer, means like this they'll say that I want some requirements, they'll give. Architects will come up with a test plan, all those things. Then the design engineers, they design the code for a system on chip processor. Then the verification engineers, what they will do, they will do the verification on that. What do you mean verification? Is the design whatever implemented, is it working properly or not? That is what they check in simple terms, I'm saying. Okay, then it goes into the backend flow. Okay, so hardware, what all things make up a mobile phone? First is the hardware actually. Hardware is not chip, processor, screen, USB port, camera, sensors, etc., right? Memory modules, etc., right? These are things which we, and there are some things which you don't see also. Software, can you see? Means you can see the screen actually, upon which some display is there, something, some GUI comes up. It's a graphical user interface, but can you see the software? Can you see the code? No, right? That's what they're saying here. What you don't see is the software actually. That is firmware. Software is made up of firmwares, operating systems, and the applications. These are all softwares of your mobile phone. Okay, what is firmwares? These are called as drivers actually. What is the example of a driver? Suppose let's say you purchased a new laptop. Today you went to some Sangeeta stores and you purchased a new laptop, Sangeeta or Chroma, wherever it is, and you came home, right? You came home and you opened your laptop to do some work. You wanted to inject a pen drive actually. You wanted to put a pen drive to your laptop, and pen drive is not working only. Means once you put a pen drive into your laptop USB port, some pop-up will come in your laptop saying that device detected, something will come. Do you agree? Online, offline, do you agree? Suppose if the device detector doesn't come actually. Okay, why it will not come? It will not come because that respective drivers might not be installed in your newly bought laptop. Some software updates need to be done. That will be the main reason. So drivers also act a very important role in connecting your laptops. Like example is USB is a hardware. Do you agree? USB is a hardware. It has one USB protocol implemented. USB core is there, and there is one function controller next to it. Function controller is nothing but in USB. For a pen drive, it is memory actually. Okay, for a printer, means printer also has a USB port, right? Means what? There's a USB controller present inside that printer. Means that printer has a USB controller to interact with your laptop, and it has a function controller. Function is what a printer does. Printer functionality it will do. Getting my point? So when any of the USB hardwares, when you connect into your laptop, if it is not getting detected, the issue will be what? Drivers might not be installed. First issue you have to start with drivers actually. It's not like your laptop is not working. So so what you'll do, you'll be checking for any software updates from your laptop. If it is there, you do it. Ideally, it has to work later that. Getting my point? So drivers, they come into picture when you want to connect to your external ports. You have external ports in your laptop, right? Not even if you want to connect some HDMI and all, right? Those respective drivers need to be installed in your laptop. Second is the operating system. Okay, Operating system is what? Whatever means using the means, see, if you want to do any operations on your laptop, right? First thing is what? OS need to be present. OS is the one which interacts with your hardware inside your laptop. The hardware interacts with your hardware actually. Why it interacts with your hardware? To do some operations. What example of operation is what? Suppose let's say today I am going to open the settings in my laptop. I'm going to open settings in my laptop. Okay. And I want to do some changes to, let's say, will display. Wait, what I'm saying is, where is the search bar? Suppose I'm going to display settings actually, and I want to change this brightness. You see the screen brightness here. Now currently it is what? Somewhere around 70% it is there. I want to change it to 100%. This is some hardware changes you are doing. Do you agree? What hardware changes? Your display brightness you're increasing. Display hardware changes is what you're doing. Right, one thing. Second thing is what? Suppose you're having you're having a hard disk. Your laptop has some internal hard disk. You want to separate that storage actually. Like one for C drives, one for D drives, and you want to split. In this D drives also you want to split actually. 256 for one and remaining 256 for other. You want to split. Those are all what? Hardware memory partitioning is what you are doing actually. Use to do that also you need to be using what? Settings of your laptop. Yes or no? OS you need to use in your laptop. You need to take care of. You need to take help of the OS. Using the OS, you need to change the some hardware of your laptop. Changing is not like now currently your laptop is terabyte storage. You want to change it to terabyte storage. That won't happen using OS. Getting my point, right? 1 terabyte to 2 terabyte you can't change it unless your laptop already has a 2 terabyte memory installed in it. Okay, what you can do, whatever the existing hardware is there, with that you can do some changes as required by you for your laptop. Even for that we make use of OS as well. How are we doing it? By using settings or some other options in my laptop. An example. Did you understand? That is where OS will come. Applications. All these applications, to do any specific task you need specific applications. Even setting is also an application. Do you agree? Setting is also an application actually. Whatever you saw the system settings here, it is also one of the applications. Whatever you see here, presentation I'm doing here, I am using PowerPoint application. I'm using, right? Internally what it is doing, using this application, what I'm doing, I'm either loading the data into my memory hardware, or I might be deleting the data from my memory hardware. Do you agree? Yes or no? Suppose when you connect a pen drive, you want to move the files either from your pen drive to your laptop, or from your laptop to pen drive. How do you do? Will you break open that pen drive and will you take that memory out and will you take the data from in hand and will you put it in your laptop? Not possible, right? I'm just saying it's not possible. What do? You first connect your pen drive to your laptop. You open that file explorer or some files icon will be there. You open that and you say that I want to share from one device to other device this particular movie file. Do you agree? Okay, that is where applications comes. To do any specific task, there are specific applications present. Okay, for messaging, for social media, what application you use? WhatsApp, Facebook, Instagram, etc. Right? Those are also applications itself. So applications run on the OS, and it's not the other way around. OS doesn't run on applications. Application run on the OS, and OS will interact with my drivers actually. OS will interact with my drivers to change the hardware inside. Okay, what do I mean by OS interact with the drivers to change the parameters is nothing but when you use a pen drive in your laptop. Suppose let's say this is a laptop. It's a laptop. Your laptop has some port here, right? Like this port will be present. This port name is, let's say, USB port. Okay, and for this port, let's say you are going to connect a pen drive. You connect a pen drive, 64 GB pen drive you connect. Okay, 64 GB pen drive you connect. Okay, now this is what you see actually. This is what you see. Now what you don't see is this one here, right? There'll be a driver. There'll be a uh, okay. What I'm saying is, let me complete it off. So here, right, you'll be having one processor actually, and here you're having a memory. Okay, your laptop memory, 1 terabyte. 1 terabyte memory is there in your laptop. This is the Intel processor what you have. Intel processor what you have. Okay, and basically it will be a processor will be present in a motherboard. There will be one board present in that processor will be present, right? So now it is not like this pen drive will be able to means Intel processor will be able to read this data and store it into this memory. It's not like directly it will happen. Okay, for those things to happen, for this processor to read the data from the pen drive and store it into the memory, you need to provide a command. You need to provide a command. Do you agree? Automatically nothing will happen. So that command is what will be given through application. That is in my case application is what? Nothing but this file manager. Okay. This application will interact with your operating system, and your operating system will interact with the respective driver. What type of driver it is? Since it's a USB connected, it's a USB driver, and OS interacts with the USB driver to fetch the data from the pen drive and store it into this external this 1 terabyte memory here. Getting my point? So for a complete laptop to work, hardware is needed and software is needed. That is what I wanted to explain you here. So how software is used, how hardware is used, I hope now it's clear for you. Do you have any questions here? Even in this pen drive, right? It's not pen drive is what? It's all about memory, right? It will be having one kind of a memory here. Do you agree? Pen drive also has a memory. Generally, in technical terms, this is called as function controller actually. Function controller. Okay, in USB terminology, pen drive, this memory is termed as a function controller. Okay, and there is one more block also will be present here. This is the USB core. USB. This is the USB actually. Getting my point? So whatever you see in this stage, right? Whatever you see the right side of this line, this blue line, it's termed as function controller. This will keep on varying with respect to the hardware. Example, printer will be having, it won't have memory. Printer will be having printer logic function controller. Right? Like printer logic means what? That printing that paper, right? Whatever Xerox is there, paper. Such a way. Understood. Now, Now, right? So most of you might be wondering that I told USB, right? So this USB is also one of the protocol present in VLSI protocol. It's a one of the communication rules, I will say, present. So in industry, there are few companies which work on USB also. So even in your mobile phone also, mobile phone or laptop, right? When you go to purchase, let me say, when you go to purchase a laptop in the store, you also see, you don't see just USB port is there. Generally, we don't see just a USB port is there. We see what type of port it is, whether it's USB 3, 3.1, or what type of port it is. We see, right? Do you agree? Yes or no? That 3 is nothing but versions. 3 is nothing but a version actually. That version will indicate how much fast the data will be transferred from one device to other device. Not only that, even when you purchase a pen drive, even there it will be written actually. If you notice, right, in Amazon or anywhere, if you notice, it will be written actually before purchasing. Like it was USB 3.1 supported or something like that. It will be present actually. That version is nothing but the how much fast it can transmit data from one device to other device. This is one example here. Okay, and there are a lot of companies which are working in this USB development as well. Okay, do you have any questions here? Electronic system. So VLSI Guru also provides USB protocol training also, but it's not part of the front end course, means front end design verification course. It's a different course actually. Okay. Now question comes: when should a person opt for USB controller? Once you get a job. Okay. Once you get a job, you'll know where you're which hardware you're working on basically. So that hardware you have to get thorough knowledge. Okay. Because when you're working in a company on a particular project, that project specific things first you have to understand. Okay. And if anything you don't know in the project specific things, you gain that knowledge. Company will provide you that knowledge also. If not, you have to gain that knowledge elsewhere. Okay. Now I told you something on drivers actually, right? I told you drivers are responsible for communicating between the two hardwares. Example is USB. Now, who is responsible for developing drivers? Is VLSI engineers responsible for developing drivers? Yes or no? Does a VLSI engineer develop the drivers?
Software engineers will develop the drivers.
Okay. Embedded engineers, they will be responsible for developing the drivers. So there is something called as embedded C language using which they will do that. So even if a VLSI engineer is working in SOC based project, they will be coming across drivers actually. See, projects, there are basic, I mean, a VLSI front end engineer can work in different types of projects actually. One, in the first category will be a SOC verification, system on chip verification, where the complete Snapdragon or a complete tensor or a complete uh, uh, bionic processor you'll be working on. Okay, that's a very huge module actually. I'll tell you, verification itself will take around 1 year. Okay, in those aspects, you are given a responsibility to verify the USB section as well. Okay, the data transactions, communication from USB to memory. That also you will be given the responsibility of. That time you might come across driver files actually. You might come across driver files, but you are not responsible for modifying these driver files if there is any problem present. Okay, you need not to open it also, to be frank. Getting my point? What is your work? Your work is only what? Apply your skills, analog UM skills of the verification. That's it. Okay. So who's responsible for that? uh, Embedded engineers will be responsible for that. Uh, okay, so basically we learned that in electronic system there are four layers. First is the hardware layer, which has processor, camera, sensors, all those things. Who is responsible for developing this? VLSI engineer will be responsible for developing this. When I say VLSI engineer, it's not only the front end engineer plus the back end engineer. Both put together is the work. Firmware, as I told you, it's all about drivers. So who developed these drivers? Embedded system engineers will be responsible for developing these drivers. Next thing is operating system. Example is Android OS, Android operating system, or iOS, or Windows operating system, or Linux. Who's responsible for this developing this OS? Software engineer. OS developers, I think the terminology is operating system developers will be present. They'll be doing it. Basically, software engineer will do this. Okay. Next, applications such as apps in mobile, like Google Pay, Maps. Even there also, software engineers, basically app developers, will be responsible for developing developing the applications. Okay. Now, in your hand, right, you might be seeing. Okay, let us discuss regarding. I think recently, which phone came out? Anyone has an idea? Recently, which phone has launched? Huh? No, iPhone. No, iPhone 16 launched long time back, right? Google. Google Pixel 10, 10 Pro, 11 series. Okay. I don't know. I'm asking that's the reason. I don't know. I didn't keep track of all those things. So Google Pixel, some phone is getting released. Okay. So today they are released, right? Means this week they released. Uh, so work for it would have been started 3 years back actually, 3 to 4 years back. Getting my point? So today, whatever the company is working on Google, the phone will be released after 3 to 4 years. That is how the timeline is there. So today they might be working with some initial stages of the project actually. RTL development stage is what I'm trying to tell you. RTL development means what? Design, writing a design. So writing a design is not a role of a verification engineer. Writing a design is not a job of a verification engineer. There are dedicated engineers for that also in the front end. They're called as RTL design engineers. If you'd have opened LinkedIn, right, you would have seen some notification saying that RTL design engineers needed, right? So front end, first thing what I told you is a RTL engineer. Second thing is a verification engineer. Getting my point? So example, how, see, I explained you in the paint how this data transaction works, right? How the software comes into picture, all those things I told you, how drivers come. Uh, some of you might not have understood this because terminologies are different. To make you understand how the hardware and the software interact with each other, we have an analogy here. Analogy is like what? Bus with passengers. A bus is there, which has passengers. The bus is like a hardware. Whatever you see the bus, it's a hardware. Driver, bus driver, I'm saying, bus driver is like a firmware drivers actually, software drivers. Bus driver is like a software drivers. Conductor is like operating system, and passengers are the applications. Okay. Now, as I told you, in my laptop, using applications, when I move a file from one device to other device, USB to laptop, when I move the files using applications, what happens first? OS will take that command, right? OS will take the inputs from the application and provide it to the driver actually. Driver will initiate the transactions between the USB to memory. Data should go. Similarly, when a passenger wants to get down, he doesn't jump actually. He doesn't jump out of a moving bus. Do you agree? Because if he jumps, I don't know whether he'll survive or not actually. Right? So what will the passenger do? If he wants to get down, will passenger go and sit in the driver's seat and apply the brake? No, right? What will he do? First he will say to the conductor, saying that, conductor, I want to get down in the next stop, he will say. Will conductor go and apply the brake? No, right? Conductor what will do when the stop comes? He will do some indication to the bus driver saying that you stop. Then bus driver will go and apply the brake. The bus will stop. Then only the passenger can get down. It's a process present. Similarly, in electronic system also, if you want to do anything, any hardware changes, right? Hardware. What is the hardware change present? What is the hardware change present in our electronic system now? Bus moving to bus getting stopped. That is the hardware change, right? Do you agree? Similarly, in electronic system also, when the bus, sorry, not bus, when you want to store the data or do any changes to the hardware, there is some set of rules or set of sequences present actually. That is from what application to the OS to the driver to the hardware, the instruction flows. Understood this point? So whatever we do through application, we do the command. We are giving the commands actually. Understood my point? So when USB driver, as an example I told you, when USB device is connected to laptop, USB device gets detected actually. As soon as you connect, a message will pop up in your laptop saying that device detected, right? So we start doing transfers. Once the device is detected, then only we do the transfers. So USB drivers, what is a driver code? Now question comes, what is driver code? Basically, it is set of assembly instructions. Now I told you it is something as embedded C, right? So what happens is basically when these drivers gets loaded into your hardware, basically they'll be converted into assembly instructions. So you do assembly. You're aware of assembly code? You means in your engineering time, microprocessor chapter will be there. In that microprocessor chapter, assembly level instructions you might have come across. Okay, that code is what gets loaded into the hardware actually. Now you don't need now in current scenario, right? The tools are advanced in such a way that if you write a C code, the C will be converted into assembly code. Okay, so generally drivers to C it will be in terms of a C code, but it will be loaded in a assembly level file. Okay, so embedded system engineers develop these USB drivers. So generally done using embedded C language. Does bus driver manufacture the bus? Tell me, does the bus driver manufacture the bus? Suppose if I am the bus driver, am I manufacturing the bus? No, right? Some company is there, Tata, for example, right? Similarly, same way, embedded engineers is only responsible for developing the drivers. Embedded engineers will not be responsible for developing the USB devices. USB devices will not be developed by embedded engineers. Uh, I think there is one company. I forgot. Recently only I was looking into it. There are some companies which develop the USB devices. Okay, so they will be responsible for developing that. I think Intel only. I think so. Intel. Suppose let's say Intel is a company which develops the USB device. They will develop the USB device. But any engineer who's working for the drivers, they won't be responsible for they won't be, suppose let's say embedded system engineer will not be responsible for developing the entire USB device. So uh, there are different engineers comes into picture, and all those engineers are handled by the company, that is Intel company. So that specific embedded engineer will only be responsible for USB driver development only. Okay, do you have any questions here? Okay. As a small example on SOC architecture, generic SOC architecture, how a SOC architecture works, how a SOC architecture looks actually. This is a basic example, generic example. It's not any specific SOC, just a basic example it is. So similarly, right, if you open, if you know some of them, some of the people working in Snapdragon, Qualcomm especially, they'll be aware of how the SoC architecture for the Snapdragon chips will look like. Okay, so a basic generic SoC architecture will look like, will be having some CPU. CPU will be consisting of what is A7, A7, A7? There are one, two, three, four. Four is there, right? These are nothing but A means ARM actually. Cortex processors, ARM processors, I'll say. ARM processors there. You know ARM company, ARM, right? They are actually major of the time they will be working on Cortex processors development. Okay, which are internally used by your you told Snapdragon, right? Snapdragon processor also use Cortex processor, ARM processor only. Even this iPhone also, Bionic processor also use the Cortex processor itself. Even your Google also Tensor processor also will use the Cortex processor itself actually. Okay, so what they'll do is this one, two, three, four. There are four A7 processors present, and there are two A15 processors are present actually. With that, there is some cache here. Cache lanes are present. L1, L2 cache is there, and with that, there is one interconnect present here. So this interconnect is responsible for communicating the CPU subsystem with the other blocks in the SoC. Okay. Then there is something called as design specific subsystems, which has GPU subsystems, and from digital DSP subsystems. And we are having USB. See, there USB 3, USB 2. See this USB 3, USB 2. USB is a protocol. That 3 and 2 indicates that versions actually. USB 3 is faster compared to USB 2. Oh yeah. Okay. Then in this high speed wire peripheral subsystem, right, there is some Ethernet also is there. Ethernet also is one of the communication protocol which you will be learning in your project, in your course, right? There is one major project implementation, means main project we call them as, that is Ethernet MAC. Okay, basically that Ethernet, you see LAN cables in your or you see LAN cables, right? You have seen LAN cables. Okay, which will be connected from one device to other device actually. Okay, not seen. Yeah, means nowadays nowadays that communication happens with respect to USB or HDMI itself. But earlier, right, laptops where the base of a laptop used to be very thick, there you used to get some LAN port actually. Okay, and now also Ethernet is there in laptops. The only thing is the way it communicates outside the laptop is different. Ethernet is still the same. Okay, so this Ethernet we also discuss in our project. In the verification, we do the verification for the Ethernet project actually. Okay, that is your last stage of your training basically. Okay, so in this Ethernet project, right, you will get a hands-on experience. Means hands-on in the sense that you'll get the actual feel of how a industry will work. Actually, how a industry will work on a project, like starting from planning stage to the verification. Okay, and then in Wi-Fi subsystem, you're having some Wi-Fi, GSM, LTE modules are there, and in iOS input output peripherals, you are having some HDMI port, MIPI is there, display is there, PMU is there, and JTAGs are there.
Sir, one question here. You mentioned here about the USB ports and all that I understood. But what about this wireless subsystem, even LTE, those are chipsets or like how is that like?
See your system, right? It also has some LTE modules will be there. Okay, that LTE module also some specific protocols will be present actually. You need to learn the protocol to implement this, but it works in the same way. How I told USB how it works, right? Similarly, LTE also works. But the only thing is LTE is not an external block actually. It's internal. It's present inside the chip itself. Okay.
Uh-huh. Okay.
Now you might ask, sir, then why are they giving here USB 3 or USB 2 here? The reason is basically, let me go a little bit deeper here. Okay. See, what I'm trying to tell you here is, okay. So what I'm telling is, this processor is there, right? Processor will not load itself to handle the transactions between pen drive to memory. Actually, point number one. Okay. What does it does actually? There will be some type of interrupts coming into picture. What does this interrupt do is, uh, see, whenever the device gets connected, whenever a USB device gets connected into your laptop port, USB port, what happens is an interrupt will be given to the interrupt controller. Actually, there will be some interrupt controllers present in your processor. Actually, okay, that interrupt controller, it will tell to the processor that there is some USB device connected. Please issue the command. Okay. So what processor will do? Processor will just say to the uh, processor. What will the processor do actually? Processor will provide a command to the USB controller present in the laptop, saying that this many number of bytes you transfer from pen drive to memory. It will say,
हेलो दोस्तों,
and that's it.
बड़ा
It will say,
इलेक्ट्रॉनिक बिजनेस
and
के
it will do its operation. So processor will give the command to the USB controller to perform some task, and please be in mute. Online guys, please be in mute. So what I'm saying is, once the device gets connected to the laptop, the interrupt goes to the interrupt controller present in the chip. That interrupt controller will indicate to the processor that there is some device being connected. It needs your attention. This is what the interrupt indicates to the processor. Once it is indicated, what does the processor does is, processor will provide the commands. What type of command? Like how much data you want to transfer from the pen drive to the internal memory, or internal memory to the pen drive. Some specific command it will provide to the USB controller. Okay. Once it performs that particular command. Okay, let me tell you one more thing also. Whatever I am writing here, whatever I wrote here, this is a USB port actually. Controller will be present in the chip itself. Here itself, controller will be present. Okay, so processor will provide the command to this controller. Then controller will take the load of interacting with the pen drive and storing the data to the memory. Getting my point? Understood? Okay. So I told you this is a chip, and we have USB controller here. This USB controller, it is part of a SoC, system on chip. That is what they are indicating in our architecture also here, USB. Similarly, PCI also will be there. Similarly, Ethernet also will be there. Similarly, Wi-Fi modules, GSM modules, LTE modules will be present. Did you understand this? Everyone, is it clear? Do you have any questions? Now I told you
I have
something
one
on
question, sir.
interrupt controller, right? In your Verilog, you're having one project, interrupt controller. There you will have a actual feel of how the interrupt controller works. Okay. What you do is, in Verilog you write the design also. You also do the verification as well in Verilog. Okay. So in Verilog, whatever the design you do, it might be for just I think 16 interrupts. It might be there. but in actual SOC, right, there will be thousand of interrupt will be the present. Okay. Function controller, see, for a pen drive, function controller has what memory actually. So this function controller will have a logic to just store the data, whatever this USB here receives the data, right? It stores into this function controller, or else if this function controller need to send the data to this memory, it won't send directly actually. Rather, this USB will read the function controller data and sends it through this port to the USB controller. USB controller will send it to the memory. Did you understand this? Okay, so for pen drive, function controller is nothing but a memory logic will be present, like storage, load and means write and read operations will be present. Okay. This we have explained. Drivers, I explained you the use case of drivers using that settings, right? Same thing it is. Use case of a driver is what? Current mobile screen turn off time is 30 seconds. I explained you the driver functionality using the display brightness actually, like changing the display brightness to 27% or making it to 100%. Right? What happens? Basically, your driver is doing the changes to the display hardware. Display will be having some registers present. Display hardware has some set of registers. For the registers, it is changing this value. Okay. What value? The display intensity, brightness intensity value. Okay. Similarly, for mobile screen turn off and turn on time, right? Current mobile screen turn off time is 30 seconds, and we want to change it for 60 seconds, let's say. How do we do it? Do we open the phone, apply number 16 on the hardware? What do you mean by that? If you want to change your mobile phone turn off time, do you break open the mobile phone, open that processor, that means display module, and you apply the number, you take a pen and write a number as that 60 on it? You don't do that, right? What happens? How do we do it? We open the settings in the mobile. We open the settings first. We go for display section in the settings. So there we change the number from 30 to 60. Right? This whatever I gave the instructions in the settings, that instruction goes to operating system. Right? OS conveys this to power management drivers. Right? So this driver consists of instructions for processor writing to a register in the design to change number from 30 to 60. So when I say hardware changes, every hardware will have some set of registers actually. You modify the register values, respective functionality will change in the design. Okay. So VLSI engineer, understanding requirement. So as a VLSI engineer, you need to understand that how the hardware works. That is what we understood by using a simple electronic system, right? Like how let's say the display brightness changes in the hardware, right? Or how pen drive, when you connect a pen drive to your laptop, how means what are the basic things present in order for that data from the pen drive to go to your laptop, right? In-depth understanding of hardware development steps is needed actually. Now here we just saw virtually, means just by we saw the diagram and we understood, but that is not the only thing. You need to also understand how the protocol works also. Like I just draw here lines to make you understand, right? But you need to understand how this to understand this, you need to know how this USB works. In-depth knowledge, if you want to know, you need to know how this USB works, how this interrupt controller works, how the communication happens here, what type of protocol they're using for communication. All those things comes. Okay. So how firmware interfaces with the hardware? Basic understanding means how firmware is what software actually. How the software interacts with your hardware. Basic understanding is sufficient. What do you mean basic understanding? That bus passenger example we saw, right? That much understanding is for a VLSI engineer. Okay. VLSI engineer don't need to understand, no need to have understanding of operating systems and applications. Don't need. Some basic what is application, what is operating system sufficient. Okay. Fine. So what we will do is we will take a break. Okay. Take a break for 10 minutes. We'll meet up at take a break for 15 minutes. We'll meet up at 11:45. Okay. After the break, I will continue with this design styles actually.
Uh,
Yeah.
Sir, actually, I went to your demo class, which has been uploaded in the YouTube channel. So is it
Okay.
like the same, like it was, the almost most of the contents were same. So is it like the same, or like it's different from that?
Most of the things will be the same only. Okay.
Okay,
Additionally, if you want to discuss anything, you can discuss at the end of the end of today's demonstration.
okay. Thank you, sir.
Okay. Okay, you can take a break. After the break, online guys, join the same link. Join by 11:45. Okay. Thank you. Yes, hello everyone. We will start with the session.
Okay, sir. Here, here.
Okay, so till now we have understood how electronic system works actually. Means how in the sense, at least in hardware point of view, some basic knowledge you have gained how it works in right. And for software point of view, you know how the things work, right? Uh, Now, in hardware, right, as we saw system on chip, for example, hardware, what we saw system on chip, Intel processors, example, right? The designing actually. Okay. Before even going into the processor, right, VLSI design styles are basically two styles are there. One is ASIC design flow, second one is the FPGA design flow. ASIC means application specific integrated circuits. FPGA means field programmable gate array. Okay. Let us understand something over those two aspects also, because in VLSI these are the two major design styles are present. Okay. First thing is, what is VLSI? Full form you have to know. What is VLSI actually? VLSI means what? Very large scale integration. What is the large scale integration you're doing? Transistors, basically. Right. So what are we integrating? Transistors. Since the transistors is integrated into a basically around lakhs of transistors are being integrated into the current chip. It's called as very large scale. When when uh, um, when chip came into concept initially, we were just using some 100 transistors only. 19th centuries we were just using hundreds of transistors itself. So we used breadboard, right? You breadboard, you know what is breadboard? We used to, you know, right? We used to check the design in the breadboard, and using soldering on the PCB board we used to implement the chip, because number of transistors was less. There is no headache. Okay. As the electronics era kept on increasing because of the demand of of us basically, what happened was more and more transistors implementation, means more and more transistors be required for integrating on a chip. As the number of transistors used in a chip kept on increasing, manually manually verifying the chip and manually integrating the chip in PCB became very difficult. What difficulty is? Human error is the difficulty. What was the major issue? So what happened that time? uh, uh, Industry moved to automation approach. Okay. What is mean automation approach? Like we don't need to manually check it. Automated procedure came, such as tools came actually. EDA playground, EDA tools, electronic design automation tools came into picture. Okay. So example is your Questa Sim. Example is Questa Sim, Synapse PCS, Wordy tools are some examples. Okay. Now, yeah, basically what I wanted to tell you was why the electronic design automation came into picture. Because as the number of transistors implemented in a chip kept on increasing, so manually testing is not was no more an option, because of human errors being present in the connectivity of one transistor to other transistors. So EDA tools came into picture. So in VLSI, in very large scale integrations, we use EDA tools for most of the things. So VLSI styles actually. So what are the design styles are present? So if you want to design a hardware, what are styles present? So a hardware can be designed by using an ASIC flow or by using a FPGA flow. ASIC flow means what? Application specific integrated circuits. Means you are developing the circuits which are meant for specific applications only. Example is your mobile phone SoC or laptop SoC, right? So mobile phone is what? Snapdragon chip or Tensor chip or any other chip, whatever is present in mobile phone, they're all application specific. Meaning what? These these chips which are being built, they can be used only for mobile phone application only. Understood my point? Second thing is what? FPGA actually. So FPGA was what? Field programmable gate array. So same FPGA board can be programmed to behave like different applications. Okay, FPGA is actually a board which comes where you can program it to behave as different applications. You can also program it to behave as what? Mobile phone also. To be frank, an FPGA board you can also program it in such a way that it can also behave like a mobile phone or a laptop. Okay. So which one looks better? Now, which one looks better actually? ASIC chip is better or FPGA board is better? FPGA board looks better, right? Because one board, multiple things you can do. Yes or no? But though it looks FPGA approach is better, however, industry prefers ASIC design flow due to low cost of manufacturing. See, ASIC is a bulk production. ASIC chips, right? They are always produced in bulk actually. So when something is ideally is what when something is manufactured in a bulk, cost of manufacturing will reduce drastically. Do you agree? If ASIC is cheaper option, then why we don't do everything ASIC? Question comes, right? Just now we discussed that ASIC is cheaper in production. Then why we don't do everything in ASIC? Right? For ASIC, initial investment is very high. Meaning, what is the meaning of this is, suppose today I want to build my company. Let's say I want to build a mobile phone manufacturing company, mobile phone chip manufacturing company like Qualcomm. I want to build. Initially, I have to invest a lot of money actually. Why a lot of money? To hire the engineers, right? To hire the engineers and other production items, all those things. I need to invest a lot of money actually. Okay, so ASIC initial investment is very high. Okay, to start up with the company, initial investment is very high. But whereas FPGA, right, boards are readily available. Boards are readily available. Yeah. So what I was saying was, cost of ASIC design flow, multi-million dollars it might take initially, since we need to start from scratch. Everything I need to do from scratch actually. So it takes some multi-million dollars. Once the flow is working, once I've set up the ASIC design flow in my company, remaining things will go cheaper for me. Okay. So cost of FPGA design flow, initial investment is less, lakhs of dollars or less. Okay. Since hardware is readily available. But per chip manufacturing cost is more actually. In terms of the simple thing what you need to understand the difference in ASIC and FPGA is first thing when it comes to manufacturing, right? ASIC initial investment is more, but per chip cost will be less because of bulk production in ASIC. In terms of FPGA, right, what happens is initial investment is less because boards are really available. Now that board I need to reprogram, and I need only few engineers for that for reprogramming. Right? So initial investment is less. Understood. But per chip manufacturing cost will be more actually in terms of FPGA. So example of FPGA board where they are using still now is in aircraft, right? In aircraft that whatever the instruments, clusters, all those things, whatever you see, there we use FPGA system there. Okay. And okay, I don't want to speak too much about this cost and all. Per chip cost, all those things are not required. So what are the advantages of ASIC over FPGA? First thing is it is cheaper. ASIC is cheaper because of bulk production. Per chip cost will be less. Consumes less die area. Do you agree? ASIC, right? It's not even very less actually. It is around now new technologies, 3 nanometer technologies and all have come, right? So it's very less. Die area means what? The area in which the chip will sit is very less. So provides flexibility to customize the design features. So nowadays, you know that a lot of variety of mobile phone models gets launched. Suppose, yeah, as someone told, Google Pixel has launched recently, right? 10, so 10 or 11, right? So there, that itself has lot of varieties. Do you agree? Some, I think some starts with 80,000 and it goes till 1 lakh 50 also, right? There are varieties of the same processor is present. What they have reduced some features, that's it, in the each processors. Yes or no? Like, suppose let's say the one which is 80,000 might not have a very good display, right? Very good display it might not have. I don't know. I have to see the spec actually. But what I'm trying to tell you is, so ASIC based chips, right? They provide flexibility to customize the design features. They customize the design features, and you can instead of launching only one mobile phone, you can launch four varieties of mobile phone having different features. The highest one will have everything. The highest costed mobile phone, that is 1 lakh 50 rupees phone, will have lot of features actually, and the lowest price will have only limited features. That is what it is. Okay. Second is the power, means next the power efficiency. ASIC chips are very low power chips. Like, if you charge, if example, right? Suppose your battery is around 5000 mAh battery. If you charge that phone for 100%, even if you do hardcore use of the mobile phone also, it will come minimum 12 hours. It will come. Yes or no? Suppose you just use your mobile phone for just messages and basic usage. Your mobile phone charge will come one day, 1.5 day it will come. Mobile phone charge, right? So ASIC chips are very power efficient chips. ASIC can work at higher frequency compared to FPGA, hence gives better performance. What is meant by frequency operation is nothing but whenever you purchase a mobile phone, right? You see that what is your operating frequency, right? How do you see that now? Like suppose 4.5 gigahertz operating frequency it will run. Okay, suppose you have two mobile phones, one which works in 4.5 gigahertz, one which works in 4 gigahertz. Which is more actually? Question to
So
you guys is, suppose you have
here you mean to say the LTE or the 5G bands, right? Basically, the higher
no, no.
frequencies.
I am not speaking regarding the communication. I am speaking regarding the chip operating frequency. What I am speaking here is specification. If you see, let's see here. Processor. So here they have not mentioned anything, but generally, right, they will be there actually. Okay, let's open the laptop. Please be in mute. Someone, please be in mute, everyone. If you don't have anything to ask, right, you can be in mute. See, what I'm saying is basically we are having this particular laptop. Okay, this laptop has a this laptop, right? It has a processor which is a Snapdragon. Its processing speed is 3 gigahertz actually. Meaning what, the instruction means whatever the command you give for the processor in 3 gigahertz frequency it can process it. That is what is the meaning actually. Okay, and similarly you will be having some other models of your laptop which is costing even more actually. Now this is 67,000, right? Something we saw here as something here we saw 67,990 something we saw, which is where the processor frequency is 3 gigahertz actually. Where is it? 3 gigahertz. Similarly, if you see some other laptop, you'll be able to see the same Snapdragon providing a 4.5 gigahertz frequency operating speed also. Now, which is faster? This is faster or this is faster? 4.5 gigahertz is faster, right? So, but cost will be more. Obviously, you have to, if you want more performance, you have to pay more for it, right? So that is what we are saying here is ASIC can work at higher frequency rate compared to FPGA. So FPGA, it might have lower frequency rate actually. It might have 2 gigahertz frequency rate, for example. Okay, we need to open the specific boards and we have to check it specifications. Okay, I will tell you what is the design flow of ASIC, what is the design flow of FPGA. I will tell you both. We'll discuss that. We have it in our discussion. Okay, basically, right? I'll discuss it. So what is the advantage of FPGA over ASIC? Okay. So first advantage is if the chip has a bug, right? So basically, FPG. See, in terms of ASIC, what happens is uh, ASIC design flow is having a front end flow as well as a back end flow. Okay. So in front end we do the design verification. In back end also they do verification. Both the places they do verification. Okay, but what happens in terms of ASIC is if a bug is not captured in its design flow during ASIC manufacturing, and in the ASIC design flow, if the bug is not captured, right, it's a loss for the company. Because if I manufacture my mobile phone after the product is launched, if you guys after using if you come to know that camera only is not working, right? What is the use of purchasing 1 lakh mobile phone actually? Waste, right? Now, do you purchase mobile phones? No, now such a way maybe 10,000 units of mobile phone I would have purchased, each 1 lakh rupees. No one purchases it. I'll be in a loss, right? So ASIC design. So in ASIC, right? Bug need to be captured in the early stages of the designing itself. That is in the design flow itself. It need to be captured. Okay, once manufactured, bug cannot be uh, uh, bug cannot be fixed. Okay, but in terms of FPGA it's not like that. FPGA boards are manufactured in versions actually, version 1, version 2, version 3, like that the boards gets manufactured. So in FPGA what happens is version 1, suppose it has some bug, let's say that bug will be, see, once FPGA board is manufactured we can't do anything. Okay, but that specific bug will be deprecated, means that particular the specific features will be deprecated in your FPGA board and the remaining features will be used. Okay, and the version which comes and the board which gets manufactured, let's say version 2, will be having the fix for the version 1 bug. That is how FPGA gets manufactured. So what,
FPGA is more like a software thing, right? Where you can increment that and then fix for further releases.
correct, in the current release I can deprecate it. Deprecate means what? Remove it in the current release. In the next board manufacturing I will fix that one, something like that it is.
So here I have one question. So in ASIC, right, you mentioned first the design part will be done and then the board manufacturing is done, right? But
Yeah,
even before the board manufacturing is done, right, you have something called as this DFT, right? Design functional
correct,
test.
correct,
So can you
correct.
provide the order of like like first comes like the design verification, DFT, or the board manufacturing? What is the hierarchy like basically?
I will tell you. See, the hierarchy starts with this actually. This is the front end ASIC design flow. Design flow has two steps. One is the front end domain, back end domain. I told you. Any hardware, these two design flow will be applicable. And for a chip to be manufactured or any hardware to be manufactured in ASIC, it starts with a front end actually. Okay, in front end, what happens? Design requirements first we get it. We get the design requirement. Okay, based on the design requirement, the architecture, the design architects we call them as. So they will take the design inputs. What are the inputs required? They'll take it design requirement, and the architecture will come up with some block diagrams and all. How my SOC should be having, what type of blocks it should be having, how the connections need to be there between the blocks, all those things. Something similar to the architect what I showed you here. This something like this architect, my this diagram, block diagram, my architect will give me. My architect will build this diagram. Okay, block diagram. Along with this, my architect also should provide me the uh, design features, everything, like what are the design features are required, all those things my design architecture should provide me. Okay, that inputs, what are the design, what are the architects comes with the plan, right? I'll say it as a plan actually. The block diagram SOC plan, it will be given as an input to the RTL designers. So designers, there'll be each engineer will be working on one set of a block actually. Okay, it might be USB block, for example. USB is one block, right? Such a way, let's say 10 designers are working on 10 blocks in my SOC. That is the job of a RTL design engineer. Develop the respective blocks of in a design. Integration engineer, what he does is he connects all of those blocks. He connects all of those blocks actually. So what do I mean by designing individual block and connecting individual block is, you see here, see basically, I'll tell you one more thing also. Qualcomm kind of company, when they manufacture Snapdragon processor, right? They don't build the A7 processor actually. They don't manufacture A7 processor. Rather, they will license it through the ARM company, and ARM will give them some RTL file. Okay, some package they will provide. And what does my Snapdragon will do is, Snapdragon will work on USB blocks, PCI blocks, Ethernet blocks, all of these individual blocks, whatever you see here, they'll work on it. Okay, and some of these blocks can also be licensed from other vendor also. See, something which is already present, why do you want to rebuild it? Rather purchase it and use it. Okay, that is more cheaper compared to building from scratch.
So
So
here, can you
individual
also add one more point? What is RTL block here means like?
RTL block means Ethernet is there, right?
Uh-huh.
Ethernet, USB, whatever you see the block square boxes here, they're all one
Mm-hmm.
block. Now this particular block in ASIC, they will be built using Verilog.
Okay.
Registered transaction level. RTL means register transaction level code. It is done through Verilog. Okay, and each block, whatever you see here, right? You name the block. See, this is some IP block is there. IP. Actually, IP, yeah, it's a generic they have given. Instead of IP, they'll be using some other blocks actually. Okay, some other name they will. IP is a generic name. So this particular high-speed wired peripherals, they're having 1, 2, 3, 4, 5, 6 blocks are there. Nothing but 6 different RTL design blocks are present.
Mm-hmm.
Did you understand now?
Yes, partly, yes.
Each RTL means registered transaction level. These blocks in ASIC are designed using Verilog language. There are some set of rules also present. If you want to write a design, there is some synthesis rules are there. You have to follow those synthesis rules, and you have to design the code. Okay. That is what RTL designers will do. Now RTL integration, whatever you see here block, right? Whatever you saw the block here. See, this is one module, or this is each blocks, right? How they are connected, how they are connected within each other, or how they need to be connected with my processor, how they need to, that kind of a logic, how the connection need to be present is what my RTL integration will do. Now this connection logic will all be given to the RTL integration engineer by the architect. Okay, what my RTL integration need to do, they have to connect it, that's it. Now pieces are there, that pieces they have to connect to make a complete SoC. Okay, now connection, it's not like just a wire connection, it's not like that. There are some protocols they have to, protocol specific connections will be there, those connections they have to do. Okay, uh, in simple terms it is like connecting your LED light to your house actually. How, getting my point, your house is a complete unit, and now you want to fix a tube light. What will you do? You purchase the tube light from the outside, or you can manufacture yourself also. Which is more cheaper? Purchasing is more cheaper, right, rather than you building it yourself, right? If something is present, go and purchase it, it's more easier. Purchase it. What you need to do in your house, if you are an RTL integration engineer, they are purchasing something from outside, or if you're building something from scratch, what you need to do, you need to connect it to your house unit, actually house electrical board, you need to connect it. Okay, the red to red, ground to ground, you connect, and your LED will glow once you turn on the light. Similar integration will be done in terms of SoC by the RTL integration engineer. They integrate the blocks. Next comes what? So RTL design plus RTL integration is completed. Next comes what? Next comes my RTL functional verification. This is where we come into picture. Design verification or functional verification, both are same. Okay, ASIC verification, different names are there, all are same itself. Okay, job. So in RTL functional verification, what we do is we verify whatever the designer has implemented, is it working properly or not, we verify. For that, we have to also write a code. What type of code? Test. We call it as a test bench. We write it by using system verilog or UVM. Okay. Next, we are having what? DFT. DFT at Verilog RTL level. DFT is also a kind of verification done. Okay, but in DFT, what they do is, DFT full form is design for testability. DFT means design for testability. What they do in terms of DFT is some test patterns will be there. Okay, those test patterns they have to generate, and they have to apply to the RTL, and they have to get the expected outputs. That is what they verify here. Okay, DFT will be done in two stages. One is in the front end stage, second one is in the back end stage also. In back end, DFT is done in a gate level. DFT at gate level is done in the back end. In front end, DFT at RTL level is done. What do you mean by RTL level is? RTL level means the Verilog code what we have. The Verilog code what we write in a human language, human understandable language. If conditions, else conditions, like that we write Verilog code. Upon that, if they do the DFT, that is called as DFT at Verilog RTL level. Then there's DFT at gate level also. Gate level means what? Whatever the RTL the designer has provided, once a green signal is given by the verification engineers on the design RTL, that design will be converted into gate level actually. Gates and gates, not gates, it will be converted. Means gates, basic gates and universal gates. All the gates are there, right? And not or XOR, every gates will be converted. That is called as gate level RTL or gate level netlist we call them as. So now you can ask a question, sir, do we need to write that logic manually? You don't need to write that logic manually, gate level logic. There are tools actually. If you remember, I told you something saying that RTL code need to be written by following synthesis rules. If you write the RTL code following synthesis rules, then you are there. There are tools such as design compiler, an example of a tool which converts my RTL to gate level. Okay, if any conversion issue is there, suppose some issue is there. Suppose let's say the design engineers has not followed the synthesis rules and he has done something. That type of bugs will be captured in this level, actually synthesis level. Getting my point? So in that stage, the synthesis engineer will go and tell to the designer saying that CPAD, like this issue I'm getting, you please rectify it and give it to me. Once the designer rectifies this, it will not go to synthesis directly. It will again go to verification engineers because there was a design code change being done. Getting my point? So what happens is that in big projects, right? There's something called as a regression. Okay, suppose my SOC has some 500 test cases. That 500 test cases will be run on weekly manner. Okay, because there might be some changes present, right? Many people will be working on the project. There might be some changes present. To keep track of those changes, if it caused a failure or a pass in my design checking, so we something called as regression goes through every week, actually. Okay, and if any failure is present, we need to analyze it. Verification engineer's role is also keeping track of the regression failures and fix it as soon as possible. Yeah, once synthesis is done, DFT at gate level. So DFT at RTL level, DFT at gate level, process is applying ATPG test patterns, you call them as. You have to apply it and you have to check whether the functionality is coming or not. Next comes the physical design. One more thing. I am not the right person to speak regarding physical design STA. Okay, because I am not expert in that chapters. Okay, so physical design, static timing analysis, then custom layout, physical verification, GDSSI extraction, fabrication, post-silicon validation, and packaging. After packaging, what happens is one more after packaging whatever we get the file, right? Again, that file will be dumped on FPGA, actually. That is the final stage of verification. Whatever the packaging we got, it's not like once this flow is done, after packaging we don't go for fabrication, mass production we don't go. Before doing that, we do one more level of verification where we apply the ASIC logic on a FPGA board. Nothing but FPGA working like a mobile phone only. If my designing being manufactured as a mobile phone, FPGA will after packaging will dump this into the FPGA board and we do one more verification, final check to see that everything is working correct. There is no issue present. Okay, then once that is completed, then only it goes to the fabrication. Fabrication means what? Sorry, not fabrication, manufacturing. Then only it goes into manufacturing. Understood? So even a ASIC chip, before it goes into manufacturing stage, it's still a verification of the ASIC chip is still done on the FPGA board. That is one more advantage of FPGA.
But sir, again, if it is done on FPGA, again, how do you test it again, right? Using with ASIC, because the flow will be different, right?
I will tell you
Uh,
what is the FPGA design flow. Also, I will explain you now. Now I explained you just the ASIC design flow, right? I'll explain you what is the FPGA design flow as well. Okay. See, in terms of, I think we have a PPT. Yeah, see here. So VLSI design flow for ASIC or the FPGA. So VLSI front end domain flow is similar in terms of ASIC or in terms of FPGA. VLSI front end design flow will be similar. The only thing is what in the design stage in ASIC we use Verilog, in FPGA we use VHDL language we use. Okay. In terms of ASIC, in the designing stage we use Verilog. In terms of FPGA designing stage we use VHDL. Okay, so in both the cases, user need to understand the design specifications. Implement the design using a Verilog or VHDL language. If it's ASIC, Verilog, FPGA, VHDL. The functional verification, what are the verification we do, right? For ASIC as well as for the FPGA remains the same only. That is system Verilog and UVM itself we use. So where do ASIC and FPGA differ? Majorly they differ in the VLSI backend flow. That is the flow starting from physical design to custom layout. That is till packaging actually. The way floor planning, placement, power planning, CTS, routing, and timing closure. These are all part of backend flow. Remains the same thing in terms of FPGA. See, when I tell you that once the ASIC design packaging is completed, it is dumped into the FPGA board. On FPGA board, the ASIC design flow software means files will be dumped into the FPGA board, and functional verification is done. Just the functional verification to check its functionality, design functionality. Okay, now is it clear?
Yeah, it is clear.
I didn't get you. Now is it clear, or you still have questions?
It is clear, sir. Yeah.
Okay. So we were discussing on, let's discuss few of the advantages of ASIC over FPGA. Okay. Advantages of FPGA over ASIC. ASIC over FPGA we have seen, right? What is the advantage of ASIC over FPGA? We have seen actually. ASIC is cheaper. ASIC board is the die area is very less, power efficient, more operating frequency compared to FPGA, right? And provides flexible for design customization. Gopal, your question is like, does this mean unless the customer requirement are freeze, we continue to work on FPGA before? No, it's not like that. So sorry, it's not like that actually, Gopal. So customer requirement, right? Mm, where is that? Yeah. See, customer requirement, initial requirements will come in the design requirement stage, but customer requirement can still keep on coming till before this stage actually. Okay, but before packaging, it needs to happen, and there will be some. I'll tell you, even not till here. Basically, customer requirement should get stopped here itself. Actually, before physical design starts, my customer requirement need to be stopped. Means need to be frozen. We call that as a RTL freeze time. In the design, in the during the project, right? There is some time frame called as RTL freeze time. Actually, in RTL freeze time, what happens is no more changes are there. When RTL freeze happens, no more RTL change can be done. That is what is the meaning. So before that, any customer requirement is there, you need to do it. Okay, that time frame is basically till here only. Okay, till DFT, till DFT. Advantage of FPGA over ASIC is what? If the chip has a bug which is detected after manufacturing, FPGA style won't incur a big cost. Meaning what? FPGA style, right? They don't go with again redoing everything. They don't do. They say that okay, this FPGA board let you get manufactured. I will fix the bug in the next version of the board. That is what they'll do. FPGA flow is quicker. Okay, since we don't start from scratch. FPGA board manufacturing, right? We don't start from a scratch actually. Okay, so since we don't start from scratch, the board is readily available. It takes. So what do I mean by FPGA flow is nothing but suppose let's say I want to implement some newer version of the flight systems actually. Okay, So I don't need to start everything from the scratch. I'll take a newer version of the FPGA board and implement the flight functionality on that board. So in fact, FPGA is used at one stage of the ASIC design flow. That is, FPGA prototyping is used to check the design behavior before it is manufactured. Okay. So what do they mean by that is, before ASIC chip gets manufactured, right? There is something called as FPGA prototyping stage. Where in FPGA prototyping stage, what they do is they keep all the ASIC packages on that FPGA prototyping board, and they check the design functionality. Okay, if it is all is working fine, it goes forward. But if something is wrong at that stage, right, again company has to go back to the verification, design and verification. That is front end actually. So tell me, what do I mean by that is, suppose after packaging, right, we keep that packages on the FPGA prototyping board, and once the verification is done, some bug is there. Okay, what happens is, again it has to go to RTL design integration stage. So whatever the time frame and the money spent by the company from here to here, they have to redo it again. Getting my point? That is again a loss for the company as well. Getting my point? So that's the reason this stage is very crucial actually. RTL functional verification engineer role is very crucial in ASIC design flows, because we are the first people who capture the bug in the design. We are the first persons who capture the bug in the design. So if we do our work properly, right, very correctly, if we do our work, then there is other people won't face much issues. Suppose if we miss out something, if we ignore it, something, nothing will happen. Like that, if you ignore, then it is like, you basically companies will remove you from the job, terminate immediate. It has happened many times. Okay, I have seen in my company itself people who have who have not captured the bug and just moved it out, means just overlooked it the bug. My manager immediately gave a termination letter for him. Okay, saying that this it's actually whatever your work you have done, it's not profit to me, it's a loss to my company. You please look. That's it. They'll say all like that, and you have to go. They don't give any time also. Okay, so we have to be very careful in that. Okay. And basically, right, in terms of customer, service based companies, what will happen is, see, service based companies meaning what? A company, let's say XYZ company, is hiring candidates to work for product based companies, right? Such as Qualcomm, TI, Micron, etc. Right. So if now service based company, they rely on the funding on the product based companies only, right? So if service based company employee does this, means does this kind of a wrong verification, what will happen? That entire, suppose let's say if it's a Qualcomm company, right, project where the candidate is working from a service based company. Suppose if there is any functional verification not done properly by him, so that is, there was a bug, but he didn't fix that bug. He left the bug as it is, and it went through, actually went to the physical design, all those stages it went through, and later they found out that this bug is there. They won't ask physical design team, or they won't ask DFT team why you didn't catch it. Okay, they'll ask function verification engineer why you didn't catch it initially itself. That is what they ask actually. Okay, and if you don't, and what will happen is, if that bug was very crucial, then what will happen is the customer will not means customer means what? Qualcomm will not further have the relation with the XYZ service based company. So meaning what? Lakhs of rupees whatever they used to get on monthly basis, it's gone actually, right? Service based company is in loss now. So what they'll do, service based company, they'll fire this guy. Why I should provide a job? Because of you, I'm getting my profit is going under loss. My company is going under loss. I'll fire you. You go. Immediate termination they'll give actually. Okay. So we have to always be very careful in this. So I explained you what is FPGA prototyping. So implementing ASIC logic on the FPGA board and check the behavior. Any issue in the design can be figured out before going to ASIC production. Before going to mass production, it can be captured in this stage. This is like a final check what you're doing. Okay. I won't discuss much on this per chip manufacturing, all those things. It's not required. So ASIC design flow, as I explained you, it has two stages, front end stage and a back end stage. So coming to the opportunities in front end as well as back end, right? Back end, right? See, design architects, right? For a fresher, it's not a role, okay? Because if you want to become an architect, you need to be having minimum 15-20 years of experience, okay? So architects, it's not the role for a fresher, but when it comes to fresher, right? You're having RTL design and integration engineer. They're called as. They're not separate. RTL design and integration engineers is one job role what you have. Basically, let me show you here actually in this diagram. It is more clear. Yeah, job roles. Front end design requirement generally marketing team, right? It's not actually a VLSI aspect, but it's a marketing team which does the design requirement. So architects comes into chip architect. They are basically people who are 10 to 15 years of experience. RTL coding is done by design engineers. RTL integration is done by RTL integration engineers. Generally these two are one engineer only. Okay, it might be, these both are considered as one engineer itself. RTL design and integration engineer, they call them as. RTL functional verification, the job role comes into functional verification engineer. Okay, so in LinkedIn, if you open, right, if you see any names such as ASIC design verification engineer, ASIC verification engineer, or design verification engineer, or functional verification engineer, all names are one and same. Okay. Second thing is what? Next is come to DFT. They see DFT on RTL, DFT on gate level, both are done by the DFT engineer itself. One engineer will be there who takes care of both the things at RTL level, at gate level also. It's not like two engineers are there, one engineer only, that is. Okay. Synthesis level, synthesis engineer will be there. A formal LEC, basically this is the check what we do on the synthesis, means whatever the gate level we get, right? First we do LEC checks, logical equivalent check actually. It's called as. It is done by formal verification engineer. Okay. Next DFT at the gate level is done. Physical design, STA engineer, layout engineers, physical verification engineers, fabrication, PSV engineer, post silicon validation. PSV means post silicon validation engineers. Then goes to packaging. Packaging is done by tools. Same PD engineer does the packaging also. Okay. So this is the job roles what is present. So a front end design verification, we come under the job role of functional verification engineers according to this PPT. Okay. In LinkedIn, you can search for ASIC verification engineers, ASIC design verification engineers, or just the design verification engineers. Okay. Now, see, let me come to ASIC team, right? Suppose, let's say, you're working in some ASIC project, how the team is split actually. So that is what, suppose it's a Snapdragon processor, if a company is working on. SOC team will be having 50, let's say team size is 50 members actually. Okay. Front end domain itself will be having 25 to 30 people. So where architect is only one, design team will be 4 to 5, functional verification will be having 15 to 20 people. So functional verification, physical design verification. These are the these are the places where more engineers are required in a project. Okay. DFT, you generally DFT, as I told you, in a project, 2 engineers is sufficient. Okay, 2 or 1 also is sufficient, to be frank, for a DFT. Okay, not more than that. Okay, STI will be having 3 to 5, and layout engineers will be having 3 to 5. So more opportunity you will be having with respect to functional verification, physical design. Okay, and based on the market scenario, DFT also might increase. Okay, but more are there in functional verification and physical design. Okay. Yeah, so this is all about the technical.
Uh,
Okay,
yeah,
one
sir.
minute.
Can
Give
you
me
explain? Can you explain one code example, like how the verification is done using code
okay,
sample?
one example. I can do
Yeah.
that. Example for understanding design and verification of a mux. Let's say 2 cross 1. See, I won't do the verification in UVM because UVM verification is a very verbose. Yeah, it is verbose, but it is more efficient actually. Okay, I can't do for Mux 2 cross 1. If I do UVM verification, it takes around 3 to 4 hours. I cannot do that. I will do simple actually.
Yeah,
Let's say,
simple example is to
yeah,
understand, sir.
using Verilog. Using Verilog, I will write design plus verification. Okay. Now, if it is for a design, right? Tell me, what do you think is a so? Say, I will go with the assumption that you guys are familiar with the multiplexer logic of 2 cross 1. Okay, if you are not familiar with it in today's session, please do not be taking tension because in digital design training, right? You will understand the multiplexer from the scratch. Okay, so what is the behavior of a multiplexer?
Combining multiple inputs into one, right? Like
Based
additional.
on the based on the select lines, the input pins, the input pins, the inputs will be driven to the output. Do you agree? Simple terms. So for a 2 cross 1 marks, if selection is 0, I0 input will be driven to output. And first, if selection is 1, I1 inputs, whatever might be the inputs of I1, it might be 1 bit or multiple bits also. Okay. Currently, I'll keep it generic saying that if selection is 1, I1 inputs will be driven to output. If selection is 0, I0 inputs will be driven to outputs. Now, this is my requirement actually. This is my design requirement. Okay. So, what will the architects do is, architect will come up with a block diagram. Architecture person will come up with a block diagram of the design. Okay. So, what is that block diagram of the design? Just a minute. Yeah, what is the block diagram? He will be writing something like this. He call this block as a mux 2 cross 1. Okay, he'll just mention all the parameters also. What are the inputs? What are the outputs? He'll mention. This might look very simple as of now because it's a very small design, right? I not I1 Y select. Select. So basically, what see along with this, my architect also will tell me that how many bits should be this I1 and I0 and this Y. Assuming it's a 1 bit actually. Assuming the bits are 1 bit. Both the inputs are 1 bit, output also will be a 1 bit output itself. Okay, architect is the one who's going to design, who's going to tell me this also. That's it. So this plus some space, some if at all this required some specification document architect will provide to the designer. Okay, generally this has no document because it's a multiplexer design. No document is required, only block diagram is sufficient for us to understand. But for some complex things, we'll be having some documents. Architect will give me some documents. So what the document will do is, it will be having some requirements of the multiplexers, of the designs actually. So what I do, I write the logic now. Now these things inputs came from architect to the design engineers. What I will do is, design engineer will write the code. Okay, so it's a Verilog. Okay, it's a Verilog. Yeah, it's a Verilog. So we'll start with module mux 2x1 I0 comma I1 comma Y, select comma Y. See, as of now, just understand in a basic level. Okay, so Verilog, anything starts with a module. In Verilog, right? You want to write any code, it should be started with a module, end module. Inside this, what we do? Port declarations we do. Port declarations. Now, what is the input port? What are the output ports of this module? That is what we declare. So input is I0 I1, select. Output is Y. Next is logic, behavior implementation, behavior implementation. Okay, so I will use a always. Okay, I always at the rate of star, or in even in simple terms, I0 comma I1 I0 comma I1 select. Then it's not comma, it is or I0 or I1 or select actually. Okay, indicating what? What does this indicate? That whenever inputs changes, the behavior need to be executed. That is what this line indicates. Okay, simple terms, I'm just keeping it very simple. Always begin end, and in at the rate, after at the rate, in the bracket, if you write any inputs, right? Generally only inputs are allowed, outputs you cannot do. So multiplexer, any of these value changes, the behavior of a multiplexer need to be executed. What is the behavior? If select is 0, if select is 0, output Y is what? I0. Else, else condition is what? Else condition indicates that else it is else indicates that it is what?
Our screen is not visible, sir. Hello, sir.
Sir just got offline.
Okay, okay, okay.
Yeah, I'm sorry, there was some network issue. See, what I was saying was, what I was saying was, design engineer has completed its work actually. That is designing the Mux 2+1. Now, can I send this to the fabrication? Means, can I send this to mass production multiplexer chip? I don't know, right? I cannot do that. Why? Because this might be some. There might be some issues present also. Bug might be present. So I need to verify this. So what I'll do? Once the designer completes its work, he'll provide this code to the what? Front-end functional verification engineers. Now, verification engineers, what they'll do? Engineers will develop the test bench using SV or UVM. Generally, in industry, SV UVM is what is used. As I told you, it takes time for me to do. 2 hours it will take. Minimum 2 hours it will take, even for a simple project. Okay, and for complex project also it takes the same 2 hours only. That is the advantage. Okay, now
Sir,
I cannot do
go ahead.
SVUVM. Yeah.
So, what is the difference, actual difference between Verilog and System Verilog? Where exactly these two are used?
See, I'll tell you. I'll tell you that as well. See, Verilog, SV, UVM. Industry approach. I'll say industry approach for designing, ASIC designing. ASIC use Verilog. Verilog or SV also. System Verilog also you can use for designing RTL writing purpose. Okay. For for test bench verification point of view, use SV and UVM style. Now why? Question comes why? Why can't I? Why isn't industry using Verilog for test bench? Question comes, right? The reason is limitations. Reason is very simple. Limitation on the language. Okay. Verilog is having limited number of Verilog or system Verilog, I would say. Verilog or SV having limited number of, sorry, Verilog or SV is having limited number of constraints, constraints in, I'll say limited number of shall I say variables. When I say variables, the features of the language I'm speaking about here. Okay, I'll say limited number of features. Okay, example of such is example is using Verilog to using Verilog, engineer have to manually uh, manually implement implement the logics to check if all the scenarios are covered of a design. What do I mean by that is, see, this multiplexer has two scenarios. One is select being 0, select being 1. Two scenarios are there. Now, in Verilog test bench, right, I have to manually write a logic to check if these two scenarios are covered or not. Inputs you will apply, but is it reaching till the design? with the design doing the operation and providing me the outputs. That kind of a logic in Verilog we have to manually write it. In SVUVM, what happens is in SVUVM there is a concept called coverage assertions 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 which does this automatically automatically. Okay, there are some concepts called as coverage and assertions in system Verilog and UVM. Basically, system Verilog provides me an option called as coverage and assertion, using which any checking in my test bench can be done. What is checking? Scenario level checking. If you want to do, it can be done automatically just by defining the class, defining the coverage in my test bench, and defining the assertions in my test bench. Some syntax still I need to use, but these syntax are not provided by the Verilog. They are provided by system Verilog. Getting my point? So so that is a limitation in Verilog actually. One limitation. Still, there are a lot of limitations present actually. Okay, this is one thing what I'm telling you. Second thing is what basically SVUVM, right? They provide us object-oriented programming language concept. Okay, but whereas Verilog is a module-based concept actually. So when something is a module-based, right, it cannot be reused multiple times. Whereas object-oriented programming language, it can be reused. Reusability will be there. Okay, that is one more thing which you will understand as you go forward, right? Like you will understand limitations one by one. Okay. Now is it clear?
Yes, sir. It is clear.
Okay. Fine. So coming to the test bench, right? So how does the test bench looks? Testbench.sv file. How does it looks? See again. It's a Verilog, right? Currently I'm writing in a Verilog. Sorry, it is Verilog. tb.v. It's a Verilog. I wrote sv. It's a Verilog. tb.v. As I told you in Verilog, whatever you do inside module, right? So write a module. End module. Give the name for the module as tb. See test bench. It need not to be connected to any other external components. So test bench will not have any ports. Test bench are not synthesizable also. You don't need to get a chip out of a test bench code. Getting my point? So you don't need to have any ports for that. You just need to have model test bench. You insert the design. Insert the mux 2x1 design. Insert the mux 2x1 design. Now how do you insert it? We have some syntax for that also to be followed. That syntax is called as design instantiation. Okay, whatever the design name you have given, provide the same name. Provide a name for the design, such as DUT, design under test. Open the bracket, close the bracket, do the connections. Okay, now to do the connections, test bench, in order to be connected to the multiplexer design, test bench need to be having some internal signals also. Those signals you declare. Test bench internal signals that needs to be connected to design. So I will say I naught underscore tb. I'll declare it as a register I naught underscore tb, register I1 underscore tb, register select underscore tb, and register y underscore tb. So these are the, since my design has 4 ports, in test bench I'm declaring these 4 internal signals. Okay, register because it's a 1 bit. Okay, I need to connect it here. I need to do the connections. And this I naught dot of I naught Okay, I'll tell you like this. So what are the multiplexer 2+1 ports are there? I0, I1, select, and Y. So if you want to connect design to test bench, right? What we need to do is, I'm just keeping it in different line for ease of understanding. These are the design ports actually. So there is some syntax present. Dot the design signal of test bench signal. Dot the design signal I0 of test bench signal I1 underscore T. Like this, we do the connections. Okay. Dot Y of Y underscore T. So this indicates that whatever I did now, right? This is called as design instantiation logic, where the required design I'm keeping it in my test bench for verification purpose. Today it's a multiplexer 2+1. Tomorrow, if it's a half adder, you need to, instead of mux 2+1, you need to add a half adder here. Understood? Over. Now for doing connections, right, means design inputs to be connected to, see, test bench will generate the inputs actually. Now how the test bench inputs to be received in the design stage, some kind of a wire connection need to be there, right? Some connections need to be there. That connection is what here I'm mentioning. 10 minutes. Okay, got this point? Last thing is what? Apply inputs. Apply inputs. Test bench. Okay, we need to generate the inputs actually. Generate the design inputs. Design inputs. How do you generate the design inputs? Just say what you want to generate. You just mention it actually. See what inputs you need to apply. What inputs you need to apply for this I0, for this I1, what to select, that you need to mention. So how you will mention that? There's something called as initial syntax. Okay, inside the syntax you have to provide it, saying that I0 underscore TB equal to 1, or you can say 1 means what? Value 1, single bit value, 1 bit value high I'm applying, I'm generating actually. So I1, similarly I1 0, select is what? Let's say 1 it is. Delay, you delay for some time, right? Due to the delay, saying that hash 5. This is how you generate the inputs. What should be I1, what should be I0, what should be I1, what should be select. Inputs you have generated. Okay, now you might be having a question saying that, sir, you have generated the inputs, how it is getting applied to the design? Because of the connection being done. Because of the connection being done in the test bench side, the signals whatever you generate here will be applied to the respective I0, I1 select of the design. Understood this point? Okay. Later, now question comes over. This is what we do. Generally in Verilog, this is what we do actually. We don't implement on doing the checks in Verilog because it's very verbose. Verbose means what? Takes too much of logics to write the check. So in Verilog, we keep it simple as it is. But ideally, you need to also write a check saying that for these inputs, expected output is what? What is expected output according to you? If select is
0.
1, what is the output of a multiplexer?
0.
0 actually. Why? Because what is I1? Has a value of 0. So what happens? Select is 1, meaning what? Output will be 0 actually. Do you agree? Now that I know, right? I know. Even you guys also know because it's a multiplexer. We know the behavior, right? But when it goes to complex things, right? Complex projects like this, we can't predict actually. Why? Because why we cannot predict? Because this is a 1 bit actually. Suppose if the selection is a 32 bit, so in such way manually injecting the ones and zeros, will it be possible for a 32-bit select lines? Not possible, right? Because 2 power 32 combinations you have to implement. Not possible, right? So what we do is we go with some randomization techniques that time, okay, to generate the random input stimulus. Getting my point? So that time checks are very much needed. Now simple logic you can write a check normally, but commonly when the number of inputs increases, right, number of combinations will increase. So you cannot manually write a check for everything. So we have to rely on the language at that point of time. That is where coverage kind of concept will be useful. Okay. Yeah, that is one advantage actually of coverage. So in Verilog, you can ask, sir, in Verilog can I implement coverage? You cannot do coverage in Verilog because Verilog language doesn't provide us any option to do that. So ideally, what is your choice? You look for some other options. You go to system Verilog in that stage. Okay. Now coming to system Verilog and UVM, which is more preferred? UVM is more preferred. Why? Because UVM is a standard implemented. It's a standard actually. It's like IEEE. How IEEE standards are there for VHDL simulations. Similarly, UVM is a private organization standard actually, which is followed by all the industry. Okay. That is what advantage of UVM. I will stop it till here itself. Okay, why? Because session is getting increased. Now our main next is what we have to do is we have to simulate this, check the waveform. That is what is our next point will be there. But for now I will stop it till here. Okay. Is it clear, everyone? Okay.
Yes, sir.
See, last thing what I want to tell you is the skills required. I want to discuss this skills requirement also for a for a person who is having who wants to learn VLSI, right? We are not having any skills requirement saying that you need to be knowing C, C++, Java, all those things to understand coding. That is Verilog, system Verilog and all. We don't say that. Even we don't also say that digital you should be knowing, nothing like that, because in our institute front end functional verification training starts itself with the digital, where all the basic things will be taught to you. Okay. Along with that, some interview uh, point of view also will be taught. How interview point of questions also will be discussed in the digital aspect. So 90% of the time you will be getting the same digital questions itself actually. Okay. Coming to Verilog, system Verilog, UVM, right? All of these three languages, all of these three subjects are related to one another. What do I mean by that? Verilog being the very basic stage one, I will say. Okay. System Verilog being stage two. Only if you know stage one, stage two you can understand. System Verilog you can understand only if you know Verilog. And UVM you will understand only you know system Verilog and Verilog. UVM is a methodology. Methodology means what? Everything in UVM is all about task and function methods, which are pre-implemented in the UVM libraries using a system Verilog language. So system Verilog becomes very important understanding before you go to UVM. Understood? Why am I saying all this? Because even I have also done the VLSI training, and I am also doing currently working for 5 years. It has been as of now. Okay, so that's the reason
Sir,
I'm
and who
saying
is
you
the
that
man? Sir, and who
if
is
you
the
know
man you are
Verilog,
working? Oh, hello, sir.
sorry.
Sir, and DV side or PD side you are working now?
No, I am actually a design verification engineer. I am working for a SOC based company. Okay,
Acha,
SOC
acha,
project is
okay.
what I'm mainly dealing with. I'm not revealing my company and all because it's some
Okay,
NDAs and all are
okay,
there. I cannot
okay.
reveal that. Okay.
Yeah,
Uh,
okay.
uh, yeah, I'll keep
Sir,
it
will you
at
teach
one.
digital? Hello, sir. Sir, will you teach digital electronics?
Will I teach?
Will you, sir? Will you teach digital electronics or total course will
No,
you teach
I
or
will
some
not
other
teach
thing that
digital
you?
electronics. first thing I'll tell you, I will not teach digital electronics. If
Okay.
anything in future comes, I'll be teaching regarding system log UVM projects mainly.
Okay,
Okay,
sir. Okay. Thank you,
that
sir.
is I will be teaching digital electronics. We are having one expert person. He will be doing that. So skill set
Okay, sir.
requirement. What I'll tell is skill set requirement, interest to learn. That's the only skill set requirement. What I will tell, interest to be learning. Okay, it might be front end, it might be back end. Interest is interest to learn is a skill set. Okay, and you have any other questions for me?
One
Almost
basic question, sir.
Yeah.
Yeah. So because it requires this design verification requires lots of coding, right? Because we are not an expert in OOPS concepts and all. But how difficult it is like to design for a complex chip, and what would be the role like in the sense like how complexity it would be like.
So your question is you are not experienced as of
No, I'm
now
not a.
for doing
I'm a
it.
very basic engineer with little knowledge on OOPS actually. So, is it okay that we can develop a complex architecture using this course after learning this course?
See, if you get 100% knowledge in Verilog by this course, you will be able to develop complex designs. Example is, see, even in our course also we are introducing FIFOs actually. FIFO, first in first out process of a memory. Even this is used in industry. Every even the SOC what I showed you, right? When that has a FIFO in it, between memories it will be present. Buffers, it's like a buffer actually. FIFO is like a buffers. Okay. FIFO, interrupt controllers. Okay. SPI, such type of projects you will be doing RTL in your course actually in Verilog course. Okay. Okay. So when I say complex project such as SOC, right? SOC also has a SPI controller also. System on chip also has a SPI, serial peripheral interface controller. This serial peripheral interface controller will be used for getting the data from sensors actually. Example of the sensor is fingerprint sensor or infrared sensors will be there in your mobile top, right? To detect your brightness also. Outside based auto brightness you keep right in your phone. How does that auto brightness work? By using this infrared sensors only. Okay, and also what is it? Fingerprint. You are having fingerprint in your mobile phone, right? Fingerprint. When you put a finger, how does that data gets captured? How it travels to the uh, internal security blocks of your processor by using SPI interface only. Okay, similarly, there are other protocols also used. So in our course, you are having these things: FIFO, interrupt controllers, SPI control. I told you where interrupt controller is used, right? Basically, your SOC, right, system on chip, will not directly do all the work. Will not directly interact with everything to do the work. Example is what your SOC will not frequently keeping on asking your USB port saying that is any device connected, any device connected, any device connected. Don't ask. If that was the case, a lot of power consumption would have happened. So what happens is your USB port will provide an interrupt to the SOC saying that something is connected to me. You please service me like that. Okay. So even this interrupt control logic is also a complex only for a fresher level. Actually, I'll tell you. So all these things we'll teach you how to do it in this Verilog course. And having Verilog basic knowledge of 100%, you can also implement and also some see also experience also matters. I'll tell you, more you do the code, more you will be familiar with how to write new logic. Okay, it's not like today only if I give you some very complex thing, you will be able to implement within one day.
Sir, your screen is not visible and even audio also.
Sir is offline right now. He'll join.
Maybe network issue.
Does anyone know sir's name? Does
I was
anyone know
gonna ask
sir's?
him after the session.
Yeah, hello. Yeah, I'm not sure why it is frequently the things are getting disconnected. Okay, Wi-Fi is getting disconnected, so I need to rejoin each time. Yeah. So what I'm telling you is, if you get 100% knowledge in Verilog course, you'll be able to implement complex designs by yourself. That much I can tell you. Okay. Yeah. Any other questions you're having?
Sir, will you be our trainer for the batch, or going to be multiple trainers, or?
See, I am actually a working professional. Okay. If I have time, I will take SV UVM projects. Okay. But there are experts, industry experts are there, and also experts who are working in as a lecturer also. Okay. Digital design, one trainer will come, one trainer. There'll be what is after digital, you'll be having Verilog also, a different trainer will come. But each of those trainers are expert in their own domain actually. Getting my point? I won't be taking anything unless if there is anything present, but I won't be taking most probably. Okay. So, but whereas 2021, right, I was actually connecting digital Verilog, system Verilog, UVM, as well as the projects for the same VLSI Guru Institute. Okay. If you can ask your seniors, they will tell you. Okay.
Sir,
Okay.
can you
So
share
you,
the
yeah.
course content details to us? What and all is covered in this particular front end verification course?
Okay. I'll share you here itself.
And this
Course
search
content.
for digital design, is it the same as when what we learnt in engineering? Is it the same or something different?
No, it is something different actually. Digital design, it's not like whatever you learned in your engineering. Okay. Basics will be taught. Basics is the same thing as of what you learned in your engineering. Plus interview discussions will be there. Interview question discussions. What do I mean by interview question discussion is, see, till today, basically there is one particular document called as digital design assignment, which has 100 plus questions. Okay, so whenever each interview happens, if the trainers see that a new question is asked in a digital design topic, that question will be added to this document. And that interview questions is what I'm saying is assignment, digital design assignment. It is that discussion also will happen. Okay, this interview question will be starting from basic questions till the advanced topics also. Okay.
Sir,
Other than that, there is no difference in digital systems.
No, other than that, there is no difference in digital systems.
So
Digital
we
design
normally
means
get the
computational.
combinational circuits, sequential circuits, and the same what we learnt in engineering plus interview questions.
Correct. Correct.
Sir, I just want to say one thing. So obviously that course structure and tracking system, that everything is very very different than others, and you. So but there is a one problem in the hybrid mode. We are, I think, 30 to 35 students still, and but the problem is that teacher focus more on the offline student because they are present there, and most of the time in the hybrid classes, teachers go to the offline student and solve their doubt, while online students just have to wait for 20 to 25 minutes. They are just
Yes, yes.
online
Actually,
focus.
she's right. She's right. She's telling right. Actually, this is happening.
and and in the end we get a very less time very to understand the running topic actually, so we get lots of doubt as and we are मतलब हम जो हमारा running class है उसको हम miss कर जाते हैं. That is the one problem in the hybrid mode actually.
Got it. So let me give you a real-time example for this. I think that will be more better. What I will tell you is, let me open the one of the group actually. Okay, you can see to yourself what happens. What happened? It's not logging in. Huh? Invalid code.
You can tell access. We know that login.
Just a minute. It's loading actually. See, what you are saying, I agree. Teachers focus on offline students more in hybrid mode. Hybrid mode. Okay. So in VLSI Guru, what happens is basically see digital for digital, right? Digital is only theory, right? But whereas Verilog, system Verilog, UVM, these are all about theory plus labs. Okay. So more. So what happens here is we are having dedicated theory sessions, dedicated lab sessions in terms of Verilog SV UVM. Okay. So basically, what will happen is in theory, right? In theory, it might be for both digital as well as the other languages, other things also. What happens is we teach we teach a topic for 15 minutes. Let's say example is half an hour. Half an hour. Just an example I'm saying here. It is a topic for half hour. So then what we do is we ask questions. We ask questions to both online and offline. First question what we ask is, did you understand the topic we ask? Now, if offline, if you don't understand, you have to tell me that you didn't understand, please repeat. If online, if you don't understand, you have to chat in the chat box, or you're free to unmute yourself and you can ask. Getting my point? That is one question what we ask. Now, if an online student ask a question, how will that question be, how can that question be missed? Do you understand my point here? What I'm asking? If an online guy asks me a question, either he unmutes or he sends a message. Generally, better to unmute and speak, because messages, right? If mass people keep on messaging, what will happen? Message will go off somewhere at the top, right? And it's not that this is the first time we are handling 50 batch people. We have also handled 120 people also. When more number of people comes, right, what happens is we split the group. We split it into two sections actually, two or three based on the number of people, and we take the sessions accordingly, ensuring that offline and online both get the sufficient knowledge. But in the session, when a trainer asks you, you have any doubt, you have to clear. It's your responsibility to clear your doubt on spot. Do you agree with that?
Yes.
Now, if you ask, we have to compulsory reply. How we can't just skip it, right? Do you agree?
Sir.
So, but
Yes.
still, what happens? Still, let's say, first is what? Ask questions in doubt. Ask questions in session, in live sessions itself. Live session only. Okay. If doubt is there,
Sir,
if doubt is there, ask question in live sessions only. Suppose let's say still it gets missed out. You are saying that still if it gets missed out. Okay. Next day you can ask, right? Next day before a new topic starts. starts, you interrupt the trainer in the between and you ask saying that, sir, yesterday you did half adder question, I didn't understand, sir, please explain one more time. We will explain you. Okay, getting my point. If still your doubt is not getting cleared, still if your not doubt is not getting cleared, post the same doubt in WhatsApp group, WhatsApp individual group with your doubt. Now, it has to be, if you have some doubts, it has to be answered in any one of these things, right? Did you get my point? The person who asked this question.
Thank you for your clarification. I'm not doubting your procedure, but that is one example about the suppose that the GVIM software that you have to started with that topic only. So when we are starting to download and the operate and started to work with that software, so the instruction will assure ki all the student in the offline class will download in their system, they work, and then in the last 15 minutes we are getting a time to solve our problem and to work with that software. It's same thing that happened with the coding. It's in the starting of digital, that binary and distance coding, they we get the questions, and if the offline student tell the answer first, then they move in the next question. So that's the problem we are facing sometimes, that is. And the understanding about that half idea, we understand or not, that you are right ki we get a time to say, yes sir, I am not understand, you can repeat it.
You still have time. See, if you still have doubt, did you do this stage? Did you post your question in individual group, or did you even ask the same thing the next question next day?
We can lack from the running topics are actually in the group now.
Sorry. Sorry, I didn't get you. Come again.
We are stuck in that particular one point ki I'm finding the error in that particular point, and when I post that problem in the group, and then we will got that solution, and that we will move the next at that time ki instructor or teacher already moved to the next topic, और हम वहीं पे stuck है अपने doubt को लेकर के.
Okay. See here, from my side, I have told you this, but see, let me clarify this with manager also. Anyhow, he also wanted to join the session and discuss few points with you guys. Okay, because actually, my time was till 1 o'clock itself. Okay, let me just hold on for a minute. Even manager wanted to discuss with you few things. Actually, you can ask these questions to him as well. He's the one who's managing the things. You can directly ask him the same thing.
Hello, sir. I hope you're still there. I just want to know, like, apart from these, like, Python is also required, Python, Linux basics, or how is that?